Hello, everybody, and thank you for joining. My name is Christian Hauschild from White Research. We're part of the consortium working on the EU Blockchain Observatory and Forum for the European Commission. It's my great pleasure to welcome you to this event on blockchain and smart contracts by the Observatory and Forum. Before we go into today's agenda, a little housekeeping. The event duration will be approximately 3 hours. If you want to ask a question, please use the Q&A functionality only. You can either ask a question with your name or anonymously. If you wish to contribute or leave a remark, please do so in the chat. During the presentations or while panels are discussing, you can write your questions in the Q&A. We will pick the most relevant ones or the ones that we think the panelists will find most relevant and discuss these with the panelists. This workshop will be recorded, but only what is said and presented on screen by panelists and moderators will be in the recording, so your questions don't appear. And the recorded version will subsequently, within a week or so, be uploaded to the Observatory and Forum's media channels. So you can share it with anybody who might not be able to join today. We will also be preparing a report, which will be published again on the same website. And if you have any issues during this event, don't hesitate to reach out to the webinar administrator through the chat. Now, back to the topic at hand. Before I go a bit more into today's agenda, just a quick note on the Blockchain Observatory and Forum, which is an initiative from the European Commission's DG Connect, and the consortium carrying out the activities include Intersoft International, the University of Nicosia, CERT, Bitfury, Open Forum Europe, Planet, and White Research. The mission of the Observatory and Forum is to monitor blockchain initiatives in Europe, produce comprehensive source of blockchain knowledge, create an attractive and transparent forum for sharing information and opinion, and make recommendations on the role the EU could play in blockchain. If you haven't already visited, which I guess you had for the registration, but in any case, you can visit it on eublockchainforum.eu. Now, back to the agenda. We have 2 panels today, each preceded by a keynote. Our first keynote is Dr. Joshua Law, Director for the Center for Distributed Ledger Technologies at the University of Malta, from whom we'll be hearing a bit about smart contracts, what they are, as well as smart contracts versus contracts, exploring challenges and solutions towards tech and law colliding. I'm sorry if I butcher anybody's names, it's really not on purpose. After this, we will have a panel, our first panel of the day, on use cases and standardization. We have some excellent panelists who will be moderated by Christina Liuchkaya, R&D project manager at CERT, and this will be followed by a Q&A on this topic of use cases and standardization. Then we will have our second keynote of the day by Professor Aguilos Callas, Chair of Cybersecurity and Privacy and Director for the Blockchain Technology Laboratory at the University of Edinburgh, who will tell us about fundamental properties and current approaches in blockchain governance. Finally, we will have our second panel, which is on legal and non-technical barriers, moderated by Dr. Yanis Revoulidis, also from the Center for Distributed Ledger Technologies at the University of Malta. And after that panel, we will also have a Q&A session. With that said, I would like to thank you all once again for joining, and I hope we will have a very interesting event. I'm confident of that. Now let me hand over to our first keynote speaker, Dr. Joshua Law.
Good afternoon, everyone. So thanks, Christian. Like Christian said, I'm going to be talking, well, first I'm going to introduce briefly what smart contracts are, and then discuss how smart contracts and the legal world is colliding and bringing technology and law together. So let's start with cash. I mean, we all know what cash is. We all know how cash works. We can transact with each other just by handing over money to each other, and that's great. But then when we started to think and started to use digital monetary systems and online payment systems, and we needed to store our money at the bank. And whenever we would transact with one another or with a website, it required that we would go through a bank. And this is because even if we use, let's say, an internet banking solution or a mobile payment solution, when I send you money, really what is happening is a message is being sent to the bank, and the bank then accepts or rejects that transaction. So really and truly, we didn't have peer-to-peer or person-to-person transactions, not until Bitcoin was proposed, really. We always had the bank and these central service providers in the middle. And what Bitcoin proposed and enabled was peer-to-peer, person-to-person transactions where there's no one in between your and my transaction when I'm actually sending you funds. So Bitcoin enabled for digital cash-like transactions, although some people might not say that it's cash-like, it's more gold-like, but let's leave that discussion for another time. So Bitcoin enabled for peer-to-peer digital transactions where there's no intermediary in between. And if you think about it, what this really achieved was the decentralization of monetary systems, where there's no central point of authority. And the way this works is by having a lot of different computers working together, a lot of different nodes, blockchain nodes working together collectively provide a single solution. In the particular case of Bitcoin and other traditional cryptocurrencies, it would provide a single shared ledger where we're keeping track of all transactions and all accounts and all balances. But that is really what all these computers working collectively provide. Now, in 2013, Ethereum was proposed, which was a blockchain as well. However, it proposed not only to provide this shared accounting system, but also to provide a way to execute programs, software on a blockchain. And it's implemented in a very similar manner to Bitcoin, so Ethereum and these other new types of blockchains, where all these different computer nodes are working together to provide not only a shared ledger for accounting, because they also do have a cryptocurrency implemented like Bitcoin, but they provide the abstraction of a single shared computer, where all these different computers around the world are working together to provide a single shared computer that we can use with no one having centralized control over this computer. And on this computer, on this abstract computer, we can upload software programs, what we call smart contracts. And anyone can upload a smart contract, and then we can all use these smart contracts around the world. Now, the nice thing about this type of abstract computer and smart contract is that there's no one who has control over the computer. No one has control over these smart contracts. So unlike a traditional computing system, if I were to create a website and you were to use it, I could log into the back end of that computer system and change all data, change all transactions, and manipulate it the way I please. In this type of computing system, no one can interfere with the logic that's encoded to it. There's no central point of authority. So what we achieved with these types of systems that now have smart contracts is the decentralization of computer systems. And as an example of what a smart contract might do, a very simple example, let's say me and you, we start a business together and we create a smart contract that provides some service. When we receive payment, we want to automatically send you 50% of the funds received, and I will take 50% of the funds received. So we'll write a smart contract, which could look like this, or it could look like code. And what it will do upon receiving these funds, it will automatically send 50% to you and send 50% to me. And no one can change this. No one can stop this code. No one can manipulate the code. There's no way that someone can use this service without this code executing. And we couldn't achieve this before, because before there was always someone maintaining a centralized system and they could interfere with that system. Similarly, we might make use not only of smart contracts for the manipulation of funds and for sending funds to different stakeholders, we might implement a voting process where different individuals in an organization may have a vote. And what the smart contract will do, when a user places a vote, it will just keep track of that user's vote, and it's done. And then another user will come along and place his vote, and so on and so forth, right? And then once all votes have been placed, the majority will be calculated for whatever motion we're voting for. And then eventually, once the majority has been calculated, someone can say, okay, who won? What motion actually won in this particular voting motion? So, and the code will do exactly what it's written to do, nothing more, nothing less. And in the code, you need to define when you will actually make progress and how your process will operate. So in this particular function where we're going to say, tell us who won, the code will first check if the majority has been calculated. And if it hasn't been calculated, it'll just stop and say, not everyone has placed their vote yet. We need to wait for everyone to place their vote. Otherwise, it will return the winning motion. And this smart contract will do exactly what it's written to do, and no one can interfere. So this is the beauty, really, of smart contracts, that it executes all this code, which we call the smart contract, on a blockchain. And because we're executing it on a blockchain, the process cannot be changed. The logic cannot be changed. The data cannot be changed. Not even the developer who created the smart contract can manipulate it in a manner that the logic is in a manner that goes against the logic that is written in the smart contract. So it will do exactly what it is written to do forever. And that's great because based upon this, we can then implement automated agreements. We look at the code or we look at that sort of English-like description, and we can say, okay, I agree with that process. I agree with you receiving 50% and me receiving 50% when someone uses this particular service. And it will do that forever, and no one can interfere with it. So this is what smart contracts really are, the automation of agreements. Now, the thing about code is code can fail, and we've seen code failing for decades since we've been writing code very early on. But now that we're using code for smart contracts, and in smart contracts that are handling monetary funds, cryptocurrencies, a bug can result in millions of euros of losses. And we've seen many instances of this over the last decade. And you can find loads of different instances of this as the days go by, more and more pop up, and they will keep popping up. And the reason is code does fail. And we need some way to make sure that our code does not fail or minimize the possibility of code failing. And the thing is, it's not only software that can have a bug, but even law can have mistakes, or a bug rather. And if this particular example, in a contract, a comma was missing. And because a comma was missing, a particular party lost $13 million because of the interpretation of this contract without that comma, even though they intended the interpretation to be different when the contract was actually formed. So even law can have problems. Now, what's the differences between legal contracts and smart contracts is that our legal contracts define obligations, what we need to do, and also consequences. If we don't undertake what we need to do, then we have to somehow make reparation for that. Smart contracts, on the other hand, do not allow for individuals to break the agreement. The agreement will do exactly what it's written to do, and we can only interact with the agreement with the limited manner that it allows us to do. So this is automated. Legal contracts, on one side though, are subjective. You can have a court, a lawyer, a judge look at them, and there's interpretation. A smart contract is not subjective, it is 100% objective. The code will do exactly what it's written to do. So a legal contract is legal enforceable, and it can be entered by one or more parties. And like I said, it involves different parties agreeing to something, and if they don't undertake their obligations, there are consequences. Now, typically, you do this because there's some benefit for you. There's both obligations, but there's also something you're going to gain from this legal contract. And our legal contracts are written by our lawyers traditionally, right? Our smart contracts, which is code, which is objective, and which does not necessarily require third parties to interact with it. Our code will do exactly what it's written to do. And our code, our smart contracts, are written by programmers, on the other hand. And you'll often hear people in this space tell you that smart contracts are neither smart nor contracts. You might hear other people tell you that smart contracts are legal contracts. And the truth is, smart contracts can be legal contracts in certain instances, and in certain instances, smart contract may not necessarily be a legally binding contract. And this causes an issue because if we are working in areas where we have different individuals working together in a business relationship, we need to make sure that these smart contracts are legally binding and not just bound because the code will do exactly what it's written to do. So there's an amount of research out there being undertaken on legal smart contracts, how to be assured that your smart contract is actually legally binding if something goes wrong inside of the tech world, how to create wrappers in the legal world to make sure that you're also legally secured. And we're undertaking some research on this at the University of Malta, but it raises some very important questions that we don't only look at smart contracts in isolation as tech and law as law, and there we have these two separate worlds. We need to see how to bridge these worlds because everything is great when the code does what it's supposed to do. But when a bug is executed or when someone loses their funds due to a vulnerability, that is where the legal system is often invoked. And people say, well, maybe in this case, code is not law, and I want to seek legal recourse. And this is the challenge that we're trying to overcome. But who would be responsible for creating these new types of legal smart contracts? So code on one side, it's a smart contract, but yet it needs to be legally sound within our laws of the land. So we need both our programmers and our lawyers to work together. And the question is, what is this actually going to look like? Are we going to have our IT professionals working in isolation and our legal professionals then seeing how they create some solution surrounding these digital systems, much like we've done in the past for traditional systems? Or perhaps will some hybrid, a new profession emerge of law grammars, law developers, these hybrids that are versed both in software development and smart contracts, as well as versed in the law and also the development and writing of legal contracts? Or do we need some form of multi and interdisciplinary teams where individuals are versed in their profession, but also capable to interact with the other professions? So do we require coders that are literate in law and able to communicate with lawyers? And do we require lawyers that are literate in code and able to communicate the various issues surrounding smart contracts? And there are many questions that surround smart contracts and the law. So one popular question is a smart contract a contract? And you often hear people giving you an absolute yes or no. It's not the case. There are certain instances where they are and certain instances where they may not be. And these questions are still questions of an academic nature that over time we'll start to see the answers being revealed as more cases go on and as more research is undertaken. But the big question remains of who will write these smart contracts. Now, our current view is that we're going to have this chimeric team, the single beast with many heads, different lawyers, different programmers who are working in a multidisciplinary team to come up with the solution, whatever that solution may be. And this is why we are heavily promoters of multidisciplinary education, that we need to be educating individuals not only in their discipline, but they need to also gain literacy in other surrounding disciplines. And the nice thing about the blockchain and the smart contract cryptocurrency space is that there are so many different facets to it, from the legal side, the computer science side, the software, the business application, but also policy and governance surrounding these types of applications. Now, if we were to look at a very simple implementation of a smart contract, all this smart contract does here is keep track of different users' ether, different users' cryptocurrency. So you can deposit and withdraw your own funds. Now we have really 3 lines of functional code here. And these 3 lines have a very infamous bug, the reentrancy bug, encoded within them. And it's because the last 2 lines are swapped around. Now, if you were to tell any software developer who's not versed or hasn't had exposure to smart contracts, they would not catch this bug. And this bug has resulted in millions of euros and dollars of losses. And so the key thing here is even simple code can be buggy. Now, in the traditional world, when we come across buggy code, what do? We update it. We find that bug, we issue a software patch, and we update this. Can we update smart contract code? Well, the short answer is no. The longer answer, not too much longer, is no and yes. So the thing is, we cannot update code. Once that code file is there, it's deployed, it can't be changed. But what we can do is when we deploy the original version of code, if we would have thought of ways to create new versions of the code, new versions of new files to be uploaded, then we can change some of the logic. And we change this logic by pointing toward this new code. But what does this mean to the users? If I create that smart contract where you get 50% and I get 50%, and I suddenly change that logic where I can take 70%, what does that mean to the users? We are losing the decentralization that these types of platforms bring. So this is an interesting question that comes to governance. Who should get to decide when we're making these types of changes? Should the majority get to decide? Should a majority of delegated representatives or developers get to decide? It's all about governance, and not just when we're talking about updating code, but also many aspects within the blockchain space. And this will lead on then to the next keynote, who will go more deep into governance issues. So I hope that you've enjoyed this talk, and if you have any questions, I'm happy to help or get in touch at a later date. Thank you.
Thank you, Joshua. I think it's time for the first panel of this fantastic workshop. Good afternoon, everyone. I think everyone can hear me, I hope. We are happy to welcome you to the first panel of the workshop today on blockchain and smart contracts. Our panel will be focused on the use cases and standardization, and I'm Kristina Levitskaya, the moderator for this panel. Let me share with you some plan for the panel. First, we will have 4 fascinating speakers driving through different aspects of the panel topic. Today, we're pleased to have Daniel Zego, Tuba Faisal, Mark Karen, and David Arroyo. Welcome, speakers. Moving on, right after all presentations are given, we will open the Q&A session for about 20 to 25 minutes. All questions, absolutely all questions to all speakers, will be addressed during this session. So please feel free to text your questions during the presentations. I will keep track of them, as well as the whole EUBOF team. In case your question arrives later, again, feel free to text, but use some identifier of the speaker you're aiming or you have in mind, like name or surname. That will increase the chances that your question will be addressed at the end. Okay, I think we are ready, not to late more. I'm giving the floor to our first speaker, Daniel Zego. Daniel, the floor is yours.
Thanks a lot. So let me just share my screen and take a look if it works. Just a second. That's right. Okay. Okay. So, good afternoon, ladies and gentlemen. My name is Daniel Zego, and I'm gonna give you a short presentation on the topic, how not to be agile in smart contract delivery. So practically, this is gonna be like, how you can be agile despite how you can somehow deliver smart contracts. That's not an easy topic to combine the two things together. So perhaps just a little bit from my side, I'm a software architect specializing actually on different distributed ledger systems. And surprisingly, my major focus is actually not the public blockchain, but rather the enterprise and consortium world, which might be more technical. But certainly, everything happening on the public permission as well is very exciting as well. So let me start with like one slide that's agile methodologies. So agile somehow started in a software development a couple of years ago, and then I would say recently it is getting to be more or try to be more actually being agile, not just in a system delivery, but in every other areas as well, like ranging from project management to organizational development and stuff like that. So I would say perhaps it's a little bit like overhyped as well to use agile, but it certainly has very good core ideas, having something in an agile way. And of course, the focus is something which is fast iteration, fast cycles, fast reaction, fast adaptation of changes, and something which is an experimentation, meaning that you don't deliver something right away in a 100% correct way, but somehow in more loops, more cycles, and then based on the previous phase, somehow collecting the experiment and the ideas basically from the first phase. There are many like tools that can be used in agile, depending if it's something which is a software delivery or something which is more like an organizational development stuff. It's like usually we have a lot of communication. It's like cross-functional, self-managing teams, quick decision making, quick cycles. If it's a software development, then quick deployments and stuff like that. So that's agile. And then I would say, on the contrary, smart contracts and especially smart contract governance is something totally different. So basically, smart contracts were designed to be as mission critical systems. So if you just consider like Bitcoin, Bitcoin has kind of a core money function, and core money function or core cryptocurrency function, I would say. So it is something that the core logic actually shouldn't be changed. It should remain relatively stable. And if you take a look on the history of Bitcoin, it is indeed very difficult to evolve the system. It's because stability is a core principle. So if you just consider something as a SegWit change in Bitcoin, it was taking like 3 years, and the system forked many times in between. And this is just for blockchain, but basically if you got something as smart contracts, the core idea is the same. So usually in smart contract, you have something as a multi-party coordination or a multi-party workflow. So there are like several hundred or thousands parties or people working together in one use case. So usually the expectation is that this system should be relatively stable. To be more specific, usually there are like two requirements or two parts of your system. One part which must be really stable and shouldn't be worked, shouldn't be changed, unless there's something which is a security bug or something similar. And sometimes there's another part of your smart contract of your system that actually can be changed. But even for the parts that is foreseen to be changed, this change process is not easy. It's again, the idea is that this is kind of a multi-party workflow, multi-party process. So you can expect that the changing actually the system requires the multi-party coordination of these parties, of these peoples as well. So in practically, that means that like if you want to change part of your system that is foreseen to be changed, you might require the coordination of several hundred or several thousand people, which is not simple. Even if it can be supported like by decision making, like you can decide with tokens, for instance, or the token holders can decide somehow changing the systems. That's kind of a tough thing. So principle smart contract governance usually has two parts: part of your system which is not foreseen to be changed, and the other one which might be changed, but it requires the coordination with several hundred or thousand parties. So basically you have this use case in each and every smart contract development. One exception if like technically you can have something as an administrator or an owner of a contract, and the owner of a contract can basically redeploy your contract every time or change your contract every time. But in such use cases, it's questionable if you need like smart contract or blockchain at all. So you have this problem actually in each and every smart contract use case. I would just highlight one specific one, that we're working on. It's more like a research or research and development project. It's a digitized money research and experimentation. What we try to do basically is that we try to implement different wholesale and cross-border digitized money use cases with different distributed ledger technologies. At the moment, the major focus is Hyperledger Bezu, which is kind of an Ethereum client driven by Hyperledger. So basically, in such use cases, these are the classical use cases like payment versus payment and payment versus delivery. Having the classical actors, I mean the banks practically. It's like commercial banks, banking authorities, or even central banks. And even in such a model, which is basically a fully controlled, fully legal use case, defining the governance decision model is tough. So defining like having a simple use case like payment versus payment, which are the parties that can actually change the system? Are they the banks? Is that the majority of banks, or is that the super majority of banks? Or is that the central bank? I mean, central bank is pretty much a big actor, but I mean, despite it's not forcing that, the central bank can change all parts of a payment versus payment use case. So having a good governance model, even in a fully legal and controlled environment, is tough. So our conclusion is basically what you can do if you want to do something agile in smart contract delivery or deployment. Our proposition, and this is basically the conclusion as well, is that you should consider like 3 phases. And the first one is something which is proof of concept, prototyping, test systems. In this phase, you can be as agile as you want. You can deliver or deploy many systems with different use cases. Then you can have the benefit of experimenting, then gaining the knowledge and the experiment of the previous phase, and with that building up your next phase. So this part typically can be as agile as you want with all the benefits of agile methodologies. But again, it's just up to prototype or proof of concept. So basically, before you want to go live with such a system, our proposition is to have a break. In this break, what you should do is basically finalize your specification, finalize your governance model, again, which are the parts of your system that can be changed and how, and which are the parts that actually shouldn't be changed unless some very specific problem happens like hacking or stuff like that. And basically, I mean, a good idea is to have like a quality assurance, especially if you are like on public blockchains. I mean, quality assurance and smart contracts audits, they are must, simple. And after this break, you can go live, and basically you have your productive system, but basically don't expect your productive system change much. So you have like certain points that is forcing to be changed, but they will be changed after long like negotiation and coordination effort. So it won't happen that this system changes on a daily basis or something. So that's our proposition, and that's actually the conclusion of my presentation as well. So basically with that, I just finished my presentation, and I'm open for questions. Actually, I don't think I'm gonna answer it right now, but I think I will have something as a panel break at the or a panel discussion at the end of the session. So thank you very much for your attention.
Thank you, Daniel. That's right. All the questions will be addressed at the end of the panel, where all the speakers will have a chance to present their projects. Thank you for the presentation. I think that was a fantastic start for our panel today. Thank you. And I think that we shall move on. The second presentation is going to be given by Tuba. Tuba, are you ready? Tuba Faisal?
Yeah. Can I share my screen now?
Yes, absolutely.
Yeah. Sure. Yeah. Okay. You guys see my screen?
I think, yeah, yes, full mode.
Okay, so I will be presenting on smart contracts and their applications in 5G and beyond. My name is Tuba Faisal. I'm a final year PhD student. I'm submitting in few months, so very finalist for the PhD. I'm also representing King's College London at CISG for PDL, permission distributed ledgers, and I have led two reports, one report and one specifications on on smart contracts, and we are preparing one more report on non-repudiation. So it's a different topic, but we will connect it to smart contracts in future. So that's my introduction, and I will be discussing about smart contract. First, we will start with the introduction of smart contracts. Security challenges related to smart contracts, as Joshua said, that they are not simple to implement and they have got problems with transparency and immutability. We will discuss them and what the steps we are taking in our ISG PDL. Designing secure smart contracts, how keeping those qualities of the smart contracts, how can we design secure and viable smart contracts for industry? And then we will discuss smart contract applications in 5G and beyond. I will be focusing on service level agreements in telcos and give you two different layers of use cases. So let's start, and then we will conclude our work in the last slide. So smart contracts. Smart contracts, as Joshua explained earlier, that there are software codes and they're installed on distributed ledgers. Distributed ledgers on their own, they're static. They don't have it. You issue a transaction, I give A to B, $5, for example. They just write it. They just write the confirmation. They don't have any execution mechanism. So they have smart contracts. So smart contracts actually are the executable codes installed on the distributed ledgers. And in distributed ledgers, every node or every participant in the ledger keep a copy of the ledger. So based on those properties of distributed ledgers, these properties are inherited by the smart contracts as well. So for example, they're immutable. So once they're recorded, they cannot be changed or amended. They're auto-executable. So the conditions that are programmed, and because they're immutable, the conditions become active or executed as soon as the condition becomes true, or they are triggered. And they're transparent. Typically every node in the network keeps the copy of the ledger. In Hyperledger Fabric, they give you the opportunity and they give you the provision to have some nodes only, the contract participants to keep the copy of the node. But that thing gets complicated when you have got 2 or 3 nodes which are actually participating in one contract. So how you can mitigate those problems? And then based on those properties, I will highlight on the security challenges because of the properties. And if you want to use smart contracts for future generation network contracts or service contracts, we need to mitigate those properties and to make them viable. So first of all, transparency. Because distributed ledgers are transparent, smart contracts are visible to all the parties in the network. So I gave you the example of Hyperledger Fabric before. So in Hyperledger Fabric, actually you can create channels in which only the participants who are participating in the contract will have the copy of the contract. Still, if we have got 2 or 3 participants or 4 participants, then we, for example, in the telcos environment, if we have got one set of vendors, one set of customers, one set of operators. The operators may be giving some special, vendors may be giving some special deals to some of the operators, but not all of the vendors. How are you gonna deal with them and cope up with them? So visibility domain needs to be clearly defined in terms of smart contracts in order to avoid unintended parties to see the actual service, or actual smart contract or actual contract. The second is auto-executable. So as Joshua mentioned earlier, that we have got a famous Dow attack in which small problem actually executed several other problems and reentrancy attack. So how we can cope up with the problem, and any single error in the smart contract, if it is deployed, can cause monetary losses or wrong executions or wrong payments. Immutability. Smart contracts cannot be changed. So if they are deployed, they are deployed. They are there and they are there forever. So you need to manage them properly. Second, because the distributed ledgers, even if they're permissioned or permissionless, they are there. So they are there for a very, very long time. Indeed, you can delete, if you want to delete the whole permissioned ledger or permissionless ledger. It's not easy, but you can delete it. You just delete it from all the nodes, but it kills the purpose of the distributed ledgers. So if old endowment contracts can actually create problem and clutter in the network, so you need to install smart contract after very, very careful planning. So you really, really want to install it, need it, and then you install it. So it's a problem. And if there is a code error in the code, it can create backdoors in the contract and can result monetary losses, as explained earlier by earlier speakers. So how we are managing those problems in our ISG, HC ISG PTL? What we are doing, in our report GR004, we have proposed a life cycle, a complete life cycle for smart contract deployment. And we say that there's a careful planning and discussion, and the collaboration is needed before the smart contract actually goes to the coding, deployment, and testing phase. Okay, and so what we did in the first planning phase, all the stakeholders, they should be sitting together and they should be designing the smart contract as per their needs. Actually, they need to define on a piece of pen and paper, or maybe Microsoft Word or Google Docs, whatever technology they want to use. But they sit together, they decide what actually they need from the smart contract, and are they complying with the standardization bodies. So SB here is a standardization body. The smart contract should, because in our GS, that's a specification, we actually define that what actually smart contracts should have. So is the smart contract, what they're going to be coded and deployed, is the checks are completed, is everything they need it's there or not? And if it's not there, they need to review the requirements from them actually. And the second step is the code verification. If all the stakeholders agree to whatever is planned and required by the smart contract or the future service or any contract, the contract can actually move on to the coding and testing phase. The coding and testing again is done on test beds, and in our GS specifications, which is PDL 11, the next report, we define actually how the smart contract can be tested and what actually the criteria for testing a smart contract. So if when the smart contract is coded and tested properly and everybody is happy, is the smart contract in the testing scenario working as per the requirements defined by the stakeholders, the smart contract moves on the deployment stage. Okay, now here I want to emphasize here is the smart contract, the termination. The smart contract technically cannot be terminated, but in our ISG PDL, we are advocating that the smart contracts should have internal timers. After those timers and after that time elapse, the smart contract should clear all the variables and become dormant. So it should not be callable by any party in any way. So that's, we call it termination of the smart contract. So we define all these specifications in our GS 00111. So based on those requirements, when we say that it is possible to design smart contracts which are actually secure and which are actually viable in industry, we move on to the applications for 5G and beyond, and we discuss that smart contract as service level agreements in telcos. And we note that, and we advocate the notion that the smart contracts, they do have the properties which are required by future generation service level agreements. And because they create accountable service level agreements, every node keeps a copy of the ledger, so it is there immutable. So you can always go back and check, and that if the service level agreement was actually honored or not in future. Automated, because they are installed on the distributed ledgers, they're automated, and then they can be and rewards and penalties can be paid without any human intervention, and almost instantly. Transparent. All the nodes which are involved in a contract, they have the copy of the ledger. They cannot make the contract changes in the contract. On this notion, I will discuss two different scenarios in which, in case of publications we discussed, the applications of smart contracts. And we published 3 articles. Actually, there are 4. The 4th article is already in the press, so I have not mentioned it. Then how to actually allocate network services instantly, just in time, through smart contracts in 5G and beyond. This project is a joint venture by King's College London, University of Cambridge, University of Surrey, and Vodafone. So what we proposed in this architecture is actually we have got operators collaboration. Every operator is actually running a blockchain node, or we advocate permissioned type of distributed ledgers in our work. The service contracts, the customers which are the operators which are offering the service contract, for example, 10 megabits per second in London, for example, or in Brussels, or in particular area of Brussels, they are advertised on a distributed application. This distributed application is accessible by the users, and the corresponding smart contracts are installed already by the operators on a distributed ledger. So we advocate actually the short-term and dynamic service level agreement service contracts for the customers, so they can choose service contracts as per their needs and as per requirements. For example, if I'm a remote surgeon and if I want to start a remote surgery, I need a very good super fast connection at a very higher price, possibly for 1 hour or 2 hours or 3 hours, I should be able to get this provision from my operator. And I will be paying for the high price because the human life might be at the stake. And if I'm watching a Netflix movie at home, I might prefer a not so good connection, but maybe my price might be priority. So that notion actually we advocate with this architecture. So the resources which are service contracts, like for the contract for service for remote surgery or for watching a Netflix movie, is advertised on a DApp. All the participants, they are running the contracts on a distributed ledger, and the corresponding service level agreements are installed on the distributed ledger. So when I need a service contract, I choose a service contract from a DApp, I press, I want to buy the contracts, make the payments, and the contract will be issued to me. I omit some details here on the service level quality of service monitoring here because of the time constraints, but interested people, they can go and check our IWQS paper, in which actually we propose a protocol through which the quality of service can be monitored, and how the customers and the operators, they both ensure that no party is cheating and lying in the scenario. Because again, we write to the blockchain, it cannot be deleted. So we ensure in this architecture that how you can actually ensure that both the parties are not lying and not cheating to the system and writing correct data to the system. So now the question is the smart contracts can be a viable solution? So why we should be using permission distributed ledgers instead of permissionless? To prove this idea and to assess and evaluate our architecture, we used both permissioned and permissionless scenarios. For permissionless scenario, we used Ropsten testnet, that's the Ethereum testnet, and the reason we used Ropsten, it's a congested network. Almost every developer wants to use Ropsten because it's free, it's easy to get your fake tokens, and we see it takes around 40 to 60 seconds to deploy a smart contract, execute a smart contract, not deploy, execute a smart contract. And similar smart contract one executed on the Hyperledger Fabric, which is a permission distributed ledger, and Quorum, it took us around 75 to 100 milliseconds. So we see there's a big difference in terms of latency in both permissioned and permissionless scenarios. So we advocate permission distributed ledgers for our case. You also note that Hyperledger Fabric actually, Quorum actually outperforms Hyperledger Fabric. So it means that's a difference between the consensus of those protocols. So when the operators and people, they want to deploy actually this architecture, they need to take into account the type of the consensus mechanism used by the permission ledgers, so they can make the right choices. The second is the infrastructure sharing. The infrastructure sharing is actually I've got So we also submitted 2 papers on this infrastructure sharing. One is will be published this month in Communications Magazine, and the other one is in preprint is available, but the future it's under the press in other. It's not in the press, it's under review in one IEEE magazine. This work is joint lecture by myself from King's and Misha, and Vodafone and Telefonica from Spain. And in this architecture, actually now, so first we defined the architecture, which was providing services to the customer, the retail customer. Now we are talking about sharing the network infrastructure. The network infrastructure we envision as in 5G and 6G as an open architecture in which multiple parties can actually own the network and or lease the network. If I am a vendor and I'm leasing a part of my network, I should be paid according to the usage of my devices. And if I'm a small player, I should be able to own the small part of the infrastructure. So all these benefits will be covered by this architecture. Again, I will say I have omitted a lot of details here, but interested users can please, interested listeners can please go and check the paper for the details. So because we want to enable device sharing and we want to enable the network sharing at the device level, we envision every device is actually permission distributed ledger enabled, a PDL enabled device, and a blockchain node enabled. So they don't have to actually run the node, but they are enabled. They should have the capability to run the node whenever it is required. And when we want to put them in the scenario where actually their sharing and their monitoring is required. The resources are monitored by the orchestration layer. It is similar to the management and orchestration layer in 3GPP. We have a PDL layer, so which is actually abstract layer, because this all nodes, if I don't know, you guys see my cursor on node. In the network layer, all the nodes, they are equipped with the PDLs. So these PDLs actually form this network infrastructure. The actual telco's network infrastructure actually forms the PDL with the PDL nodes. And this is how we enable device sharing. Then whoever needs network services, they can actually ask network orchestration layer. And based on the access rights, they actually able to lease the network resources, and the whole process is managed by the governance, which is actually the representatives of the owners and the releasers of the network infrastructure. So I have omitted a lot of details because of the time constraint, but please do read the paper. So now how we evaluated this idea? We evaluated this idea again on the Ethereum, but we use GNS3, in which we run a PDL node on 3 different devices. There is a governance node, which is connected to all of the nodes. And then we have this PDL node. We have a packet processor, that's our algorithms, which are running inside to monitor the device usage. And the governance is also managing the whole network infrastructure, that no party is actually cheating and abusing the system. And all the devices are getting the right services. We used Ethereum's CLIP protocol here, and we see that actually the latency to run the smart contract is gone down to 4 seconds here. Here we want to highlight the notion that because we run these sub nodes on a laptop, so on the laptop, the device resources are shared among different softwares. For example, we have GNS3. On top of GNS3, we have got different virtual containers on which these devices are connected, are shared. We have an operating system which is actually also sharing that I think 3 gigahertz of our CPU. So we say that it took 4 milliseconds in our laptop, but we should anticipate a far better performance when we use actually specialized hardware for network resources. And also this latency is lower than the latency, as I mentioned earlier, which was in 10 milliseconds, but that depends on the protocol against. There we used quorum, and here we used Cling protocol. Here we used a different scenario. So we say that actually when the designers are designing the system, the smart contracts are actually a viable system, but they need to take few things in consideration. For example, the protocol for the permission distributed ledgers, and the design of the network. That's very important to consider. On this note, I would like to conclude my work, and I would say that the smart contracts indeed provides a viable mechanism because they are transparent, auto-executable, and immutable, and they are very they have a huge potential to be used as service level agreements for future. But we need some planning, and we need some consideration, and we need to look into many things and design make our choices very carefully. And standardization activities are very, very important, and we are actually doing really good on the standardization part. In our ISGPDL, we have introduced several full specifications on smart contracts. I know other standardization bodies such as ISO and IEEE, they are working really, really good on this part. So we have very high hopes for smart contracts to be used as service level agreements and other type of contracts for future networks. Thank you very much, and I would stop sharing now.
Thank you, Tuba.
Thank you very much.
Great presentation, a lot of crucial details. Thank you. You got many questions, so I think that will be addressed during the Q&A session. And we are moving to the next speaker, Mark Cudden. Mark, the floor is yours.
Hi, how you doing? I'm just going to share my screen now. Which screen? This one. Let me know if you can see my screen.
Yes, we can do. Yep.
Okay, so I'm going to talk about using a smart contract in trade. So I'm just going to very quickly just go through with you. Oops, let me just minimize that one. Let me just very quickly go through in terms of trade. So my name is Mark Gooden, and I work for We.Trade. I'm the CTO of We.Trade at the first blockchain based digital trade finance platform in production. We've been in production since about 2019. We started as a POC in Ethereum, and then very quickly moved to Hyperledger Fabric, open source, open governance, enterprise permissioned blockchain technology. The area that we really focus on is addressing the challenges of the SME European trade with the delivery of a robust digital trade network supported by a concrete rule book. I will actually talk later on about a rule book, the need for a rule book in our domain, and how we actually link that then into smart contracts. Again, We.Trade it's a joint venture. It's owned by 11 European banks, a business information provider, and technology provider IBM. Here, I'm really going to talk now about the unique value of a blockchain. So really, before we kind of get down into the smart contracts, we have a look at, in terms of, why blockchain. And if we have a look at current processes on the top row, you can actually see then, there are a lot more steps. Some of these steps may be manual or out of process steps. When people are looking at blockchain, they're looking at really in terms of it's a multi-party system. So that's one of the big values of blockchain, that it's a multi-party system, and it maintains and records data in a way that multiple stakeholders can confidently and securely share the data at the same time, and they're all kind of on a needs basis. Those who need to have access to the information can have access to the information, and those who need to have a restricted view of that information can also have a restricted view of that information. And this is some of the inherent, principles and benefits of using a blockchain-based system. When people are kind of looking at, you can do non-blockchain systems, and then you can actually go for optimized and digitized. And all you're going to do there is really kind of reduce some of the, maybe manual steps, or just bring in process efficiencies. But then really, when you have a look at a blockchain system, you're really looking at, the benefits in terms of reducing complexity in terms of time and cost, because you're able to use distributed ledger, which you can use in terms of reconciliation. The smart contracts you can actually use again as the previous speakers spoke about, in terms of using the execution of of settlement conditions and based on the settlement conditions of the smart contract. With blockchain, we have inherent cryptography from a security perspective, and then we have immutability from the finality of data. I like to always then share about the 4 core blockchain solution building blocks. We have a shared ledger, and again, shared ledgers are recorded once and append only. Again, this really does eliminate the duplication, that is, inherent in traditional business systems or business networks. All networks participants have access to the distributed ledger, and it's immutable. Now, again, there are ways, okay, if you're on a public and permissionless blockchain, then you've got more access to, shall we say, you've got more access to various information, whereas when you're on a permissioned network, you effectively can restrict down who can see what. With Hyperledger Fabric, and we are built on Hyperledger Fabric, you can use a channels architecture. That was an old type of architecture, or you can actually use what we use now, which is the private data collections, which is literally just a way in terms of data, what we class as data segregation and segmentation in terms of who can see what. Inherent in blockchain, again, like I said before, it's all about cryptography, and again, it's just ensuring authentication and verifiable transactions. The big piece about blockchain-based systems is it's a trust system, and it's really using the trust system to verify the transactions. And I prefer to use the term trust systems over consensus, because not all validation on a blockchain network is done through consensus. Specifically, even if you're in a permissioned blockchain network. And then again, trust comes from the immutability of the data. Smart contracts, again, these are the terms that are, these are business terms that are embedded into a business or into a blockchain transaction database, and they are executed with transactions. They're considered to be the rules of a blockchain-based solution, and so we need to define the flow of the value of the state of each and every transaction. Again, we don't talk about, again, one of the reasons why we talk about smart contracts is, again, we talk about regulations and certifications. When you're building a system, we're not just putting a smart contract out there, for the world just to take, or, for users to use. We actually have to build them with a business, within the business context, within the business mindset. So when actually building any system, and it's not even just a blockchain-based system, there are various different, regulations and certifications that one still needs to apply. These, these can be industry regulations, they could be geographical regulations. But we still need to make sure that our systems, and they're not just the smart contracts, but our overall systems are compliant with any regulations that they need to adhere to. I've mentioned a few here that we, obviously have to adhere to, from a GDPR, and everybody knows the questions about whether blockchain is compatible with GDPR. I can attest that from a WeTrade perspective, and what we've done, it absolutely is and can be. PSD2 for payments, ISO certifications, SOC 2 for running infrastructure, FIPS 140-2 if you're running and storing your cryptographic signing materials in HSMs. And then I put in a last one, which may or may not be applicable to everybody, is really about a rule book, which a rule book for a blockchain network, or particularly a blockchain network like WeTrade. We have a rule book that governs the behavior of all the participants on the network. When we actually then go into the smart contract, we're really talking about smart contracts in terms of, we need the business, and they need to be able to design how they actually, and define how they actually interact with one another at the business level first, and here you can actually talk about terms like, creating a ubiquitous language, making sure that the business actually understand one another. Before you actually even bring in your technical people, you need to be able to understand, the common terms, the data and the rules, what happens in terms of the process flows. What are the current process flows? What are the new process flows that you want to introduce? All of these need to be actually discussed at a business level first. When you take all of these together, then you may actually be creating a new business model. And again, you need to have a look at the interactions of all of the different participants, within that business model and that business network. And effectively then we take a lot of the business rules, the flows, and it could even be legal rules and flows and regulations. We take all of those and we actually encode them into a digital version of a contract, and then one that can be executed by the computer. That's effectively what we're doing. We're actually introducing the smart contract. Again, smart contracts generate multi-party transactions. And again, this is the power of blockchains being a multi-party systems. If I would say, like, if you're going to use, I see blockchain and smart contracts, their strengths really lie in multi-party systems and multi-party transactions. If you're looking at doing a single organization system, then I would ask the question: is blockchain really the key technology that you want to use there? Because it is harder to develop blockchain based systems. So I would say, like, really just having a look at selecting the right technology for the right business use case. Like I said, a business network is full of multi-party transactions, and these are actually governed by the actual contracts. And then again, smart contracts are typically used for the execution of agreements, so settlement conditions, or contractual clauses as part of a normal contract. You look at the actual settlement conditions, and then they effectively will, execute without an intermediary's involvement. So you don't need to get a third party involved in terms of, the execution of that smart contract. And again, smart contracts are actually used to automate a workflow execution, and particularly when settlement conditions are met. Putting, smart contracts to work in terms of we trade, what we do. So again, traditional trade with a lack of trust, because buyer seller may not actually know each other. All of these parties may not actually intimately know each other, and therefore the trust may not be there in terms of how they actually engage with one another. This is normal traditional trade or trade finance flows today. There's a lot of chatter, inter participants communications, and a lot of things can get lost. So it becomes it's uneasy and inefficient. Lack of visibility of the end-to-end transaction. It's paper-based, lack of trust, open to risk and fraud, especially with people changing bank account details, or if a man-in-the-middle attack in terms of changing bank account details, which could actually result in financial loss. And it's error-prone. Again, from a buyer perspective, there may be a need for prepayment. From a seller's perspective, there's an impact on liquidity. In other words, they're not able to, if they don't get paid by the buyer, then their business is at risk. So there's a lot of risk actually, applied today in terms of traditional trading. And then for the buyer and the seller, they can actually agree or disagree on the payment terms, which again could actually impact businesses on both sides. From a blockchain-enabled trade finance platform or a trade finance platform such as WeTrade, we effectively, through the use of smart contracts, we actually make it so much easier and efficient access to finance for buyer and the seller. We increase the visibility of the end-to-end transaction, because we effectively now have all of these parties and many, many more parties actually coming onto the platform. So rather than kind of being very much in a disconnected style and kind of using email, phone calls, and all other forms of communications, we actually, all communications is done on a platform, and a lot of these communications is actually in real time. And again, not everything, we have a mixture between blockchain and non-blockchain elements, so we don't overuse smart contracts, because as the previous speaker said, there is an overhead in terms of developing and maintaining smart contracts. So one then needs to be very, very careful about how many smart contracts one develops, again, to make sure that you can actually manage and maintain your code base. Specifically, when you go into production and when you're running production systems. Again, from a WeTrade perspective, we kind of, by bringing all of the parties onto the platform, we reduce paper-based processing, because we are effectively at the forefront of digitizing an industry that hasn't been digitized for about 150 years. There's a lot of movement in this space over the last 4 or 5 years, because blockchain is actually seen as the technology that can address the needs of the participants that actually engage in trade. From a buyer's perspective, again, we use smart contracts to offer, bank payment undertakings. From a buyer's bank, for example, we use smart contracts to actually stipulate that the buyer has actually attained a bank payment taken from their bank. From a seller's perspective, they can actually see that the buyer has got a bank payment undertaken, and therefore it removes the risk from them about not being paid. So again, it's all about who actually see, you know, what information relating to the trade. And again, we use the properties of the smart contract to be able to drive that from a securitization perspective. From a seller perspective, we look at removing the risk of non-payment and liquidity, because again, it's all underpinned by a smart contract. Now, from a WeTrade's perspective, we also have a rule book, because we're operating in a space that there are no standards and no real rules at the moment. So we've been applying in the open account space in international trade. So we have actually created a legal rule book, and then we've actually encodified that rule book into a set or in a series of smart contracts. Okay, and then when people and then when institutions and corporates actually come onto our platform, they actually sign up to, because their legal people are used to actually looking at legal documents, so they will actually sign up to the legal document, and then effectively all execution done on the platform is done via the smart contracts, where we have full conformance between the smart contracts and the legal contracts. From an end-to-end perspective, in terms of what we actually look at doing, so this is where we talk about bringing multiple parties together on a platform, and then underpinning all of you know, all of the interactions between the parties are the smart contracts. So you can actually use, and it is not just one smart contract for the whole system. You're going to have a series of smart contracts depending on the offer and the capabilities, the products and the services that you make available on your platform. Okay, so I know we've kind of run over time. So from a maintenance and a delivery perspective, while it's difficult to do continuous integration and continuous deployment with a blockchain-based solution, I will say that it's not impossible. WeTrade today, we currently do continuous deployment and Kanban, agile Kanban with CI/CD to production, even in a blockchain-based system. I'd say it's easier for us in that sense, because we are a permissioned network, and therefore we are business network operators, and the governance is with us. We are a consortium, so therefore, we have that, our governance structure is actually set in place to give us that autonomy to do that, but it's not impossible to do CI/CD to production with blockchain-based solutions. And I'll hand it back to yourself, Christina.
Thank you, Mark. Personally, I got lots of insights during your talk. Thanks for that. Okay. We are gradually moving towards the end of the panel, but yet we have one more speaker, David Arroyo. David, please step in.
David, I don't know if it's just me, but I can't hear you.
David, can you hear us? I would propose maybe to turn off the camera just in case that, we have a problem. Could you share something? Just say something to confirm that we can hear you well.
Unfortunately, we don't seem to be able to hear you.
Oh.
Perhaps what we could do is address a question, give David a chance to get the audio working, and then come back to him after the question. Christina?
Yes, can you, I can hear you. And I was so I don't see a problem to share the, Well, this using this moment, probably I would like to ask someone from the EUBOF team, the administrators. Would you like to guide us here?
Now?
Yes.
Yeah, it's possible. Now, can you hear me now?
Yeah,
Yes, I can hear you now.
I think.
Yeah, because there was a problem. I don't know. I have changed the configuration and now I think it's working. And I guess if I share now the screen, you can see my screen now.
Yep.
Yeah. So sorry for the inconvenience. This is David Arroyo from the Spanish Research Council. Here I'm going to summarize some of the main works we are performing in the context of the Spanish standardization body. But I'm gonna cover some related outcome of some of our research in the context of blockchain and distributed ledger technology. And first of all, in the previous talks, we have tackled the very concept of smart contract. From my point of view, I'm going to be provocative here. From my point of view, there is a very problematic abuse of language when we are talking about the smart contract. From my point of view, it is not accurate to talk about the smart contract since they are not in proper terms something that is smart. It's something that can be automatically executed when some specific conditions are met. And in addition, in plenty of occasions, we cannot talk about contracts, and we should avoid the use of contracts in this case, because somehow we are trying to avoid the myth about neutral law, but at the same time we are being trapped by another myth, the myth of neutral technology, and we don't have neutral law. But I'm afraid we don't even have a neutral technology. So this is something very important to have here. What we are going to try to underline is that in plenty of occasions, this kind of abuse of language and many of the different initiatives is propelling the overabundance of trust in untrustworthy systems. For sure, the underlying systems are credible and sometimes dependable systems, but they are not totally trustworthy. And what we have to be working on is in the development of trustworthy systems, not only trusted systems, but trustworthy systems. This is something that is very important in the very context of a smart contract, for example, because in many occasions we are assuming that the developing of a smart contract are solving some of the very well-known problems in the development of secure software. And as a matter of fact, in a smart contract, we have almost the same problems we have in another context, with the additional complexity that in plenty of occasions, continuous integration is not possible to achieve in a fast and efficient way. Here we have a summary of different vulnerabilities that can be analyzed in detail if we perform an exhaustive pen testing, for example, of smart contracts. And plenty of them are very common in the general scope of software development. These kind of vulnerabilities are almost the same as if we were working in web development or any kind of other type of software development. As a matter of fact, the main problem we have here is that we are not performing a proper and secure development of software, which is a main problem in the huge ecosystem of software development. So this is something we have to take into account. We are not solving security problems in software development by adopting blockchain or distributed ledger technologies. As a matter of fact, we are going to have the same problem and maybe even more complicated problem. Why? Because we are right now, for example, incorporating plenty of different things in order to translate information from one blockchain to another using the so-called blockchain bridges. The so-called blockchain bridges incorporate a very risky scenario that should be tackled in a proper way, in a different way, because we have here maybe a backdoor that can be used in order to centralize the decentralized systems. This is something very important to take into account, that for sure is not always a solution that can be achieved by means of a smart contract, but it should be taken into account in order to have a proper and accurate vector of attack models. And these are another attack very common in this very scenario. We have analyzed this kind of problems in the very general scope of dependable and credible system in order to build a more robust connection between trust and trustworthiness. When we are talking about blockchain, we insist in highlighting that blockchain and distributed ledger technology are trust machines. Okay, but this trust machine must be verified. We cannot be taken for granted that we can trust this system without a proper verification. Take into account plenty of different problems that have been recorded in the past regarding governance scheme and regarding different attacks. So we have to take this into account. And we cannot forget that the algorithmic governance should be complemented with a proper, for example, corporate governance of a proper social governance. Otherwise, we are not tackling the big problems we have right now in the digital ecosystem. In these both words, we analyze this kind of problem, and we also propose in another words different governance scheme in order to address this very demanding problem. It's something that we should be working in order to for sure, in order to construct and develop a blockchain-based proof of origin and authenticity, for example. We can use blockchain for this content. It's possible, but we have to combine in a very careful way the cryptographic ledger we have in a blockchain ecosystem, the communication ledger we have in this ecosystem, and finally, the common interest between the different actors in a blockchain ecosystem. These three ledgers must be properly integrated, and we cannot assume that, for example, if we have an application ledger that is robust, the whole system is going to be robust, because maybe we have a problem in the network protocol. Take into account that most of the blockchain solutions that are developed in this very moment, they are deployed upon a cloud system that are out of control of the community. In plenty of occasions, they are out of the control, for example, of Europe. And for example, a very simple, it's not so simple, but it's a very classical attack, for example, to BGP can make very weak the whole ecosystem, even if we have a very robust cryptographic ledger, because everything is upon a cloud that is out of our control. And that is a very important concern to take into account. For sure, we can develop different layers in order to conduct authentication, authorization, audits, and accountability in order to protect the data lifecycle. But we have to take into account that in the end, we have an internet protocol that is the one upon which we are deploying blockchain and distributed ledger technology. That's the reason why it's so important to have a cloud system with a proper governance scheme. Otherwise, maybe when we are talking about decentralization, we are talking about another different thing. And if we have this kind of configuration, for sure, we can design proper oracles in order to gather critical tracking events and key data elements through different interfaces that can be used to get data in an automatic way, in a semi-automatic way, or with the intervention of a human being. This type of different intervention are necessary in order to have a proper governance scheme. And we have to take into account that the governance of the whole system cannot be solved just implementing smart contracts. We need to combine these three different modalities of intervention in the whole life cycle of the data. Otherwise, we are going to have maybe a trusted system, but maybe this system is going to be untrustworthy. And this is very important to take into account. And as a matter of fact, this problem has been a very well-studied problem in the very context of the governance of the technology. And in specific in the context of artificial intelligence, where plenty of different proposals are targeted at developing human-in-the-loop proposal in order to combine the intervention of the human being with automatic procedures, in order to have something more than a smart contract, in order to finally achieve the automation of specific procedures in the generation and exploitation of contracts. And this is something very useful. We have not to be always obsessed about automation. Automation is very good, but it should be combined with something that can be properly managed and understood according to some specific definition of transparency and accountability. This is something very, very important. And in this vein, we can talk about the inclusion of the human in the loop related to both decision taking and decision making. But also, in general terms, we should work on the development of society in the loop in order to have, for example, proper check and balances systems, in order to foster the incorporation into decision making and decision taking the different actors with competing interests. This is something very, very, very important for the sustainability of our digital ecosystem. We need to have people with different interests in common in order to proper articulate a check and balances system. Otherwise, the trust machine maybe is not so trustworthy. And in the end, in addition, we need to be sure that the devices that are gathering the information are trustworthy. This is something we are trying to develop in the context of the European project, the secure platform for ICT system rooted at the silicon manufacturing process project. There we are taking into account that right now in our European space we have a very critical problem related to technological independence. As a matter of fact, we don't have the capability of manufacturing our own microprocessors, and this is a very important problem, because we have a dependency with respect to external actors that maybe the information is going to be recorded and it cannot be tampered. But can we be sure about the trustworthiness of this information? Can we be sure about the way the information is going to be processed by this kind of devices? We have to analyze that. In order to avoid this kind of dependency, as a matter of fact, the European Commission has propelled different initiatives in order to promote the creation of our own microprocessor infrastructure. The SPIRS project is targeted to develop root of trust, what it means is to generate cryptographic keys with a high level of robustness at the silicon level, at the physical level, and after that, using an open hardware, the RISC-V, to create trusted platform modules. We cannot have trust if we don't have trusted platform modules. We need this, and in order to have trusted platform modules, we need our own technology. We need that. This is something very important. Everything, for sure, software is a very good solution, but we need hardware in order to be trustworthy, in order to have trustworthy software. And we can apply this kind of approach to very different scenarios. For example, we can perform monitoring of a structure using different sensors, and finally using this sensor data in order to extract physimetrics. What I mean is something that is equivalent to biometrics, but related to the physical property of for example, of a structure. With this physimetric, along with the root of trust, the identity rooted at the silicon level, we can generate a solid and robust identity. And with this identity, we can perform authentication, authorization, accountability, and auditability, which is something very important in order to finally have a sustainable system. This is something that is gonna be part of this project, which comprises this roadmap, and we are very devoted in order to have a very solid framework to conduct remote attestation. We need remote attestation in order to be sure that, for example, IoT devices are trustworthy. Otherwise, we are gathering information with not a clear information about the credibility of this data. We need to perform active monitoring of the credibility of any endpoint in our system, because the information that is recorded in a blockchain is immutable, but it doesn't mean that it's a reliable information. It has to be previously curated, and the curation of this information involves, for sure, automatic procedures, but also semi-automatic procedures, and finally, human intervention. So we need to foster interoperability and human inclusion in decision taking and decision making, for sure, with the help and leveraging blockchain and distributed ledger technologies, but not only using distributed ledger technologies and blockchain. This technology is part of the solution, but it's not the solution itself. And this is also part of our main roadmap in another project, where we are very concerned about the development of this off-chain governance that can be based on some on-chain solution, but also we have to take into account another problem, for example, related to the development of quantum computation, which can be a very serious problem in the very real context of any kind of system performing data verification using classical digital signatures and hashes. We need to assess and to take into account this new risk, because it's something that for sure is not so close, but is closer today. And also we need to take into account that the types of risks we are assuming in this disruptive environment are evolving, and we need evolving ways of modeling these new types of threats. So we need, for example, to develop something based in adversarial risk analysis, which is a part very, very specific of artificial intelligence, which is targeted at modeling in an adaptive way the way that the attackers are trying to get the benefit from the system. And this is all from my side. Thank you very much.
Thank you very much, David. That wasn't the presentation full of energy, the right energy, I have to say. And apologies at the beginning, I thought that I'm talking to you. That was my confusion. Apologies. I think we're running slightly out of time, and I have to introduce you to the second keynote speaker that we have today, Professor Kiyas. Hello, welcome.
Hello there. Let's see also if I can get my camera running. Hello, everyone. Do you hear me well?
Absolutely.
Okay, excellent. Thank you. Thank you very much for the invitation. I'm gonna just for a second use here the interface to share a set of slides that will be helpful to follow a bit what I have to say. So the topic of my presentation here is an overview of blockchain governance. And let me go just right ahead to why it's a very important topic to understand from different angles. Blockchain systems promise decentralization. This is one of the sort of main selling points of the technology. And a frequent tenet that we hear in that context is that code is law. But changing code, changing the software that is supporting a particular blockchain system, in a setting like this, it's needless to say, it can be a very difficult task. It can also be quite controversial. In first and second generation cryptocurrencies, for example, Bitcoin and Ethereum, the process is mostly centralized or is entirely off-chain. So the way basically that the ecosystem, if you want, of a particular project is governed is essentially an unstructured off-chain process. So this has led to a lot of disagreement, sometimes fierce debate within the community. And it also has led to hard forks that has split projects. So for instance, just two examples that I'm sure like you all are familiar or you heard about is the Bitcoin Cash example, where it resulted from the fierce debate in the community regarding the scalability of the Bitcoin protocol. This focused around the SegWit upgrade of Bitcoin, which was positively received in general, but also led to a lot of disagreement. And then other systems actually were created forking out of Bitcoin, in particular Bitcoin Cash, which took a different approach to how scalability should be handled by increasing more drastically the block size and the amount of information that can be transmitted per block. Another famous hard fork is that the one that resulted from the infamous Dow hack. The Dow was, if you think about it, an investor-directed venture capital fund. It was huge, exciting news at the time. It attracted, it was by far the most important smart contract of Ethereum at the time. And unfortunately, what happened is, like, shortly, not too long after its introduction, it was found to be vulnerable to an attack that resulted to an exploit and the draining of a very significant amount of funds from the smart contract. The community was split in the way that it should handle this. It was clear, it was a part of the community that said, we have to correct what happened. A lot of people lost money, including people that were working on Ethereum for a long time. So the concept was that it is very reasonable that the platform, let's say, should bail out the incorrect contract. And there was another part of the community that said, there's nothing wrong with the platform. Decentralization is about running these systems, you know, in the way they're coded, and thus code is low would imply that the system should remain as it is. Now, these are items that deal with problems in permissionless open blockchains, but certainly the issue of blockchain governance, it cuts across every distributed or decentralized system. Any system that runs across different organizations becomes an important topic for how it should be properly governed. And what we observe in the last few years with, let's call them next generation cryptocurrencies, post Ethereum and Bitcoin, including Cardano, Polkadot, Tezos, and others, is that they have taken steps to incorporate formal on-chain methods to facilitate governance decisions. And this is a very complex landscape, which I would like to help a little bit appreciate and approach. There is a lot of different, it's a multidisciplinary field by nature, and we're talking about elements that coming both from the side of political science and corporate organization, as well as social choice, game theory, cryptography. There are many areas that come together and aim at developing this set of processes and functions that we would like these systems to satisfy in the context of an on-chain governance protocol. Now, at the moment, if you try to understand what blockchain governance is that there is not a unifying theory. There is not enough information out there to help you understand what are the relevant requirements. What are we supposed to expect from a formal governance system? And what are the relevant problems that one should keep in mind when a system like that is deployed. So the motivation of this work that I'm presenting to you now is to systematize the properties of these blockchain governance protocols and give you a classification of what different blockchain projects have done so far. So in the course of this work, we have reviewed literature, both academic and gray literature, blockchain white paper literature, to understand what are the different properties that a governance system should satisfy. And then we want to project them in the context of these blockchain projects. So this is the list of the 7 properties that we identify as essential. And in the next few slides, I'm going to give you an overview about these properties and what do they mean. So first I'll start with confidentiality. And this is an important property which is classical in voting systems. We're all familiar with. And actually you can break it down to various different flavors or angles. In all cases, it deals with the fact that should I be able, with a specific input to a governance process, should I identify what is my personal choice? And this cuts across many different relevant aspects. For example, it's about the privacy that I should have in making my own mind. It's about my ability or my hopefully inability to sell my vote if that is not desired, or my ability to protect myself from being coerced to vote or voice an opinion in a certain way. So these are all differences of confidentiality which come into play in the context of governance and have to be reflected or have to be considered, at least, in the context of any governance systems and blockchain governance as well. I have to say, like, the setting of blockchain governance is also even more particularly interesting in the context of confidentiality, because using smart contracts and other on-chain infrastructure, it might be possible to organize, fast track, let's say, the selling of votes, and thus it might be possible for people to influence decision-making in a substantial way. Now, verifiability is the second property, and it's a complement to confidentiality and deals with the question whether I'm capable of verifying whether the end result is correctly computed based on the input that it has received, based on the input that the system has received. It's worth saying that most current approaches that we see right now in the blockchain space, they use completely unencrypted election mechanisms, and hence they don't have confidentiality. And in this case, it's more easy to derive end-to-end verifiability guarantees. Actually, verifiability becomes particularly interesting when you have its interplay with confidentiality, as in fact, all of you that have done research in e-voting systems or voting systems in general in the past, you might be familiar with. So moving on from this more, let's say, if you want, security, classical security properties, we have Pareto efficiency, which is the crucial property from the point of social choice. The question that is raised here is that the outcome of the governance system should align with the collective desire of the community. And those of you that are familiar with social choice theory, you would immediately identify that this is really like a non-trivial requirement. We know that there's an optimal voting system where 3 or more candidates to choose from. And the concept of optimality here is something that social choice and election theory has debated for centuries. We know, for example, like that there are pathological settings like the Condorcet cycle that, suggest that the natural concept of winning cannot be supported. So the question that we try to address, if we look at the governance systems from this point of view, is to say, is it possible to determine or extract the candidate that aligns an outcome that aligns with the desires of the people that participate? There are important results in election and social choice theory, for example, Arrow's theorem, that points to why this is something that could be impossible to satisfy certain requirements. And the fact is that in any non-trivial case, we cannot prevent situations such as voters operating in a strategic way. To summarize what would be Pareto efficiency in our context, I would just distill like a simple weak description, which basically says that if we have two possible outcomes and every voter likes outcome A at least as much as outcome B, while some voters strictly prefer A to B, then the voting system, it should not produce ever the choice B over A. It sounds like a simple requirement. However, as we will see, many governance systems are not capable of satisfying it. Moving along, as I don't have much time, unfortunately, to go into more detail, accountability deals with the issue of holding those that participate responsible for the decisions they contribute to. So users who bring in a change should be held responsible in some way or accountable for that change by the platform. You can also alternatively think about it when you make a decision, what's the skin in the game that you have about the outcome of that decision? And this level of accountability is something that, for example, we've seen also a lot discussed in actual elections and in political science context. So famous example, for example, the effects of Brexit, for instance, in the UK, were driven by a portion of the electorate that might belong, let's say, in the older ages, and the effects of Brexit, for example, might not have been felt by them. So this is sort of a classical example right now in the recent literature about accountability. Sustainability, on the other hand, deals with a fundamental problem that is exacerbated in the context of Bitcoin, of blockchain systems, and sometimes in the relevant literature is referred to as rational ignorance. The complexity of those systems is high, and the effort required by a contributor to a decision-making process might be so high that the value that they get from participating is too small to justify the effort of making an informed choice. So this is a fundamental question, again, across the whole space of governance systems. And as I said, it manifests very strongly in the context of blockchain governance. Participants of the governance process should be somehow rewarded for their effort, and successful improvement to the code base in the system should be somehow sustained and supported. Moving on now to property 6, which is liveness. And in a nutshell, liveness basically says that sometimes it's crucial that decision-making happens swiftly. In other words, it's important for the system to be able to incorporate the urgency of a particular decision. Sometimes having no decision at all can be really as bad as making a wrong decision. And finally, the complex issue of suffrage, which suggests that the crucial question of who is eligible to participate, who participates in the decision-making process. And in the blockchain governance setting, we can identify many different hues of suffrage. who are the relevant stakeholders? And again, given like we only have really little time, I'm not going to go into the particular flavors of suffrage, but this is yet another important question about how we view governance. So based on this, I'm just going to give you a snapshot without going over it of the current set of blockchain systems and how do they rank with respect to these properties. And without going over into details, the only thing I will have as a comment is that, as you can see, most systems do not satisfy, not only they miss some properties, but they miss most properties. So this is a suggestion that as much as sophisticated and growing is the domain of blockchain governance, we still have a lot to understand and implement in the context of these systems. Now, with this, I'm going to wrap up, as I believe I'm already a bit over time. However, if there is more time, I would be very happy to go back. And if there are questions, I'll be very happy to go back and discuss with you any of these items which I presented, either the properties themselves or the comparison of the different systems. Also, those of you that are interested in understanding further this systematization effort, we have an extensive technical report that you can find on the link that I point out here. And I should say this is joint work with my colleague Philip Lazos. And you will find in the link that I have here in the middle of the page, the paper that includes not only the definitions of these properties and the rationale behind them, but you will also find in this report the description of the different systems and the way that they have been classified. So thank you for your attention, and I'll be very happy to get comments and questions.
Thank you very much, Professor Kayas, for the presentation, which was very insightful and very interesting. And I think it allows us to perfectly now move to the second panel for today, which I would like to briefly introduce. First of all, thank you for staying for the second panel as well. And welcome to the second panel. My name is Ioannis Revolidis, and I am a law lecturer at the University of Malta, both at the Law Faculty and at the Center for Distributed Ledger Technologies, working with Dr. Joshua Lul, who took part in the first panel on issues of blockchain design, technology, and regulation. And I will be moderating the second panel, which focuses mostly on legal issues surrounding smart contracts. This panel consists of 4 participants. We will have 3 synchronous and 1 asynchronous presentation. And our panelists come from different backgrounds, which guarantees different insights. So plentiful views on our main subject today, which is smart contracts. I only have 2 kind requests, one for the panelists and one for the audience. For the panelists, I would like to kindly ask you to remain loyal to our time schedule as humanly possible. Each one of you has 10 minutes at their disposal, so please try to stick to it so that we can accommodate also the Q&A session. And for the audience, I would like to kindly remind you that if you have any questions, please do not use the chat function. Please use the dedicated Q&A section where you can share your questions so that our panelists can interact with you. Without much further ado, I would like to briefly introduce our first panelist, which is As Costello. She's a lawyer in financial services law, privacy, and blockchain. And she also is chair of the Privacy Working Group of the International Association for Trusted Blockchain Applications. So I think that we will learn a lot from her intervention. She will talk about smart contracts and DAOs, and I would like to kindly ask her to take up the floor. Ash, the floor is yours. Thank you very much.
Thanks very much, Ioannis. And thank you to the Observatory and for inviting me to talk to you today about smart contracts and in particular DAOs, decentralized autonomous organizations. So I thought when I heard the the Observatory we're hosting this chat today about smart contracts, I thought it would be really interesting to talk about a project that I've been working on for the past few months, which has been to do a privacy analysis of one of the biggest DAOs that there is. So it's still, in terms of, companies relatively new, and I'm going to say kudos to them for getting in privacy by design while they're still, building their core units. They wanted to get the privacy analysis done to build it right. So first of all, what is a DAO? So a DAO is a decentralized autonomous organization. What is that? That is, it's a company, or is it a company? So it's an organization that operates like a company, which isn't necessarily a company, and often it's not a company. It is just, if you think of a traditional company, a hotel or a multinational, you have a board of directors, you have an executive committee, and then underneath all of that, you have your HR department, your finance, your operations department, you have all those different departments. And so a DAO, by contrast, then is random people who come together, who decide, who volunteer to take up one of those departments. And they, so it's really fascinating. And so, for example, so why would that happen? I mean, the difference when you look at it, when you see how it works, it's absolutely fascinating. It is a peer-to-peer situation. Some countries consider them as general partnerships. Other countries, they're looking at whether or not they should be companies, or whether, how to actually recognize this. Currently, a lot of them don't have legal corporate personality. So how do they actually enforce contracts? So the DAO as a concept is fantastic. I think all companies will probably gravitate to being DAOs in the future, because why wouldn't you? They work on an automated basis. So they use smart contracts to automate all the processes between all the different departments. DAOs are smart contracts are their building blocks, which make all that peer-to-peer and decentralization possible. But I know a lot of my colleagues on the panel with me today and earlier during the course of the day have discussed whether or not smart contracts can actually function as contracts. Can they actually incorporate all the elements necessary, for your offer, your acceptance, and everything else that you need, certainty of terms? Can it build in everything that a contract builds in? And I know when you're building, a contract, an actual written contract, you try and anticipate everything possible into that contract. So presumably, smart legal contracts eventually will just be codified versions of the written contract. But can this also incorporate, privacy by design? My colleague who's just finished speaking there was talking about governance, and this sits very nicely with his talk, because when you're building a blockchain, or when you're building a DAO, even more so than a blockchain, you need to think about governance. You need to think about, building it to be privacy compliant. Can the smart contracts incorporate all of that? When you look at, well, GDPR is the law that we looked at over the past few months. So we were looking at personal data. And I know the EU Commission and the Parliament have recently launched a lot of other data acts. For example, the Data Act has recently been launched. The Data Governance Act is another, one of their laws, which is really fascinating. But from the personal data perspective, which is governed by GDPR, GDPR is actually quite simple. It's personal data. Is personal data involved? Who is it? Who is involved? How are they processing that data and doing what with that data? So it's quite simple when you look at it that way. Is it personal data or is it not? In the context then of this, as I described it, this sort of vague association of people and acting together in concert, towards a goal, which is what a DAO is. Are they processors? Are they controllers? Who decides what's going to happen with this piece of data? Who decides who's a client? How do you determine where the data comes from? How do you determine who's doing what to the data? And unlike a traditional organization where the board of directors decide we're going to be a hotel, this is the service we're going to offer. The DAO, it has maybe for example, they're often financial. They're there to issue tokens and make money. Some of them can do potentially other things. So how do you determine what the processing of this data is, how it's going to be carried out, all of that? So again, that is something that is currently being done by smart contracts, but can the smart contracts incorporate all of those and also the governance aspects and the privacy aspects? So that's a lot to ask of a smart contract. When you are in the project we've just finished, looking at all those core units working in concert together, we came to the conclusion that they were joint controllers. So I'm sure we're all, very familiar, and we love to death, GDPR. So you've got your processor, your controller, and your joint controller. And when you're trying to determine who does what, the controller, controls the data. So they decide what's going to happen to the data, who's going to process it, how they're going to process it. The joint controllership then, they work together in concert. They decide how the data is going to be processed. Joint means or joint purposes. So in a DAO, people are loosely working together, for a joint purpose, making money. Means may be separate, but there is a joint purpose. To get to this conclusion, we analyzed the smart contracts. We did a deep dive into the actual smart contracts. So the contracts we looked at, were the governance, the polling contract, the token smart contracts, the continuous operation smart contract, and those were the three main ones that we looked at. So we needed to see the money flows, where the money was coming from. If you want to know who the boss is, who the client is, you follow the money. They're the ones paying. They're the ones, essentially controlling the data. Where the data is coming from, the data flows as well, the recipients of the data. So a lot of analysis of, where the instructions are coming from led us to believe that, there was a joint controllership situation. Also, the way DAOs function is really, it's a meritocracy in a way. People join a DAO and you become a peer. So you buy your token, and then you're, depending on the DAO, you are eligible to vote on how that DAO is going to act. So you, as a voter, as a token holder, potentially, depending on the type of token you have, can vote on how that DAO operates. That means you are essentially also one of the joint controllers of this data. So when you look at it like that, you're just a token holder. You buy something on Revolut or whatever, Binance or whatever, Kraken, and then you get one of these tokens. Does that mean you're a joint controller of all the random bits of personal data that is housed in this DAO? So that, there's a lot of questions. If you're in the core unit, you're a facilitator, for example, and you're actively involved in the DAO, definitely you're a joint controller. But for the looser body, if you're So it's a huge area in terms of GDPR, trying to figure out who is what, where is the data coming and going, who is controlling what. And then, you like to think about, GDPR compliance, all the rules that we're familiar with. We go to any website, we see the cookies, we see the transparency notices. We are, policing your data this way and that way. We're sending it here, we're sending it there. If you're a DAO, how do you track that? How do you, put your notices up? Where do you put your notices? And also, as well, we're sick to death of, oh, I consent to this, I don't consent to that. How do you consent to whatever is happening with your data when you don't know where it's going or what's happening with it? So this is something that's really interesting as well. Where's the point where, people consent or don't consent? In one, so we're used to kind of, there was the UK decided over the last few years that in blockchain, you don't potentially need to decide whether or not someone is a processor or controller. Maybe that's going to happen here. You've consented to join the Bitcoin blockchain, therefore you've consented to your data being public. Is the same thing going to happen with DAOs? You've consented, you have volunteered to join a DAO, therefore do you volunteer for your actions and your data to be public knowledge? The thing with DAOs is everything is public. So if you want to set up a core unit of a DAO, you propose it, you propose everything about your core units to everybody. The voters decide whether or not, if you've decided you want to create the HR, core unit of a DAO, you make a proposal to the voters, to the token holders, to the other core units. You say, I'm going to pay myself this, I'm going to hire these people, I'm going to operate this way, this is what we're going to do. And then the voters go yes or no. So as you can see, there's a lot of personal data there, and it's public and it's permanent. So, and that is just, the initial stages. And then after that, it's the interaction. So the smart contracts in a DAO, they have to capture all of that. Or else if they don't capture it, how do you capture it? And how do you make sure it all works together seamlessly in a compliant way? And how do you make sure it stays up to date with, changes to regulations, changes to laws, changes to jurisdiction, the global aspect of all of that? So it is, it's a really interesting development of blockchain and smart contract technology.
Thank you very much. That has been a very practical presentation, in the sense that you really touched upon on the actual realities, and it is always nice to put things into perspective. I will keep, from the several points that you've made, I'll keep two. First of all, I agree with you that we ask too much from smart contracts. If I know anything from privacy compliance and governance in such institutions like DAOs, the contracts that we usually use are all about creative vagueness and confident uncertainty. And it is fascinating to see how we can do that through smart contracts. And also, thank you very much for remaining compliant with the time frame of 10 minutes, but definitely worth discussing these points. The other point is that you mentioned the EU Data Act, and that is something that I would like to discuss with all of the panelists of the second panel at the end. I think, thank you very much, Ash. That was an excellent presentation. I think I will now pass the floor to Thibaut Strebel. As a short introduction, Thibaut is an associate professor at the VU Amsterdam. He's also a faculty affiliate at the Stanford University's Codex Center. And he has been a fellow academic who has been working extensively on issues of blockchain regulation. Those of us following the developments definitely know about his book on antitrust and blockchain. In fact, as part of his activities, also at the Stanford University's Codex Center, he has also been working on antitrust and issues of blockchains. And he has also authored a very interesting report for the European Commission on smart contracts, taking a legal and technological approach at the same time. So I think that we will definitely benefit a lot from his insights. Thibaut will be touching upon issues of legal and technical barriers on smart contracts, and I would like to pass the floor to him.
Thank you very much. It's a double pressure on top of my shoulders. Not only you are on time, Hash, so I do have to be on time as well. And you said that my talk is going to be interesting, so I'm going to try my best to manage expectations. I think the work that the Observatory has been doing is fantastic. So indeed, in those 10 minutes, what I want to do is to try to give a flavor of the work I've been doing in the space. For that, I will just share just a few slides, if I may. As you can see, there are lots of issues that we could cover, of course, and one is the issue of competition law. I will not touch upon this issue. I just wanted to put it there to let you know that if you have questions, of course, you could always send me an email, and I'm more than happy to engage in a conversation. But if I go to the issue of contract law and smart contracts, I think overall the issue is the following, at least for me. It's to find the right balance when it comes to adopting smart contracts and making sure that it can flourish, and at the same time retaining the ability to enforce the law. So I've put rule of law, but it's actually more on the enforcement side, at least in my view. And so specifically with contract law, I think we have three different items. The first one is the one of clarifying the rules that exist already, which of course for the most part were not taken with smart contract in mind. And so in that regard, we have different legal issues when it comes to the creation, to understanding what is a smart contract, maybe to enforcement. For the creation of it, I just want to show you that it's very complex to take contract law and try to move that into the realm of blockchain and smart contracts. First, we do have, of course, disclosure rules, especially when it's concerned a B2C, so professional to consumer relationship. You have to disclose what the contract is all about. And I wonder if the issue is not even more pressing when it comes to smart contracts, especially if they are coded in Solidity or Rust and not in natural language. And we have also issues as to when do we have an exchange of consent, of course. And there, it's unfortunately a bit unclear. It doesn't mean that smart contract can't be valid, but for instance, can we recognize that the deployment of a smart contract is an offer, meaning that someone calling a smart contract is accepting the offer, or is it just an invitation to negotiate? We don't have any answer. And same when it comes to actually the automatic exchange of consent. Do we have an exchange of consent when someone is calling my smart contract or not? No answer to those questions. It's just a matter, of course, of putting the right rules in the right place. But I think it's important that we do that. the question of the medium, of course, is very important. Then it depends on each countries in Europe. But if I take the example of France, my country, it is the rule says that if you buy a property, if you buy an apartment, it has to be on a durable medium. The question is, will we recognize blockchain as being such a durable medium or not? Again, no answer. Same for the signature. Is it okay to just sign a smart contract with your public key? Is it something being recognized as being valid? It's really hard to say. So we have all of those issues here. I've mentioned the issues of performance. Here, I just wanted to show you those two graphs, and I think you may, I mean, of course, you're aware of that we have more smart contracts being called than the ones being created and living on the blockchain. Why? Because some smart contracts are being called numerous times. They also come and go, they disappear. So it's very interesting from a competition angle. But if I go to the issues of performance, maybe an idea would be to say that, you know, regulating all the smart contracts is something which is too complex for now. And we could potentially start with those smart contracts being called upon billions of times, right? So that's an idea. And if I leave for just a minute the field of contract law and try to see what is the implication of data protection or data localization? I mean, we've been discussing those, so I won't mention again the right to be forgotten and all the issues. I just wanted to show that when it comes to data sovereignty, it might be problematic for smart contracts, right? Because it is stored on the chain, which might be, of course, outside the borders of just one country. And yet we see that there are more and more such regulations. So I see a clear conflict between those regulations and the deployment of smart contracts. And the AI Act, if you look at the definition, it says that expert systems and statistical systems are AI. And my question is, well, can't we actually fit smart contract within the definition? I think, unfortunately, the answer might be positive. And I'm saying, unfortunately, not because I'm against regulation, but because if you look at the obligations of the AI Act, then I think it will become increasingly hard to comply, meaning knowing that, of course, the governance system is behind a smart contract is decentralized. So we have to take into consideration those specificities and maybe work on the definition of the AI Act. So that's item number one. Item number two, new rules and mechanisms. And you mentioned indeed the Data Act, and I will talk about it very briefly, although there is a lot we could say about it already. An idea which is very popular is the one of creating templates, right? And it seems like a good idea. If indeed smart contracts are being used, why not creating a template in which you will have a kill switch function that will allow people to stop a smart contract if they want to. But I think there is also a danger, which is that if, let's say, the European Commission creates such a template, then you re-centralize all smart contracts, basically, right? You have to trust that the Commission will design the right template. And of course, it can't be done because each smart contract may have different needs. So maybe the template for the entire smart contract is not such a good idea. I don't know, something to be discussed. It seems to me that an idea would be to study the one of creating templates for the oracles. Why? Not for the sake of transmitting the data, but potentially because this is where you may actually reinsert legal expertise and cut data being sent from A to B to call on the smart contract if legal conditions are not actually fulfilled. I will come back on this issue, but in any case, with this idea of the template, what we see is that there are different degrees. So if I go back to my example of creating a kill switch function, it could be that we say, okay, we implement that in all smart contracts. That's a template, but only the creator of the smart contract can actually call on the switch function. Or you could say, well, no, only legal institutions can do that. Or a majority of all the blockchain users can vote and call on such functions. And this actually triggers the question of the Data Act. I've reproduced here on the screen Article 30. And you see that it says that smart contracts shall include internal functions which can reset or instruct the contract to stop or interrupt their operation. It concerns the smart contract in data sharing. And it's a bit unclear, but of course it's just a draft. But it could be that those functions will be indeed potentially activated by just the creator, or it could be that we have different degrees of those possibilities here. So that is something, of course, we shall discuss. Item number 3, start with the technology. And indeed, you mentioned that in this report that I've written for the European Commission, in the context of the Data Act, I argued for what I call a law plus technology approach, which consists of saying that sometimes it might be that combining legal and technical solutions might actually work best, than just taking a law from above and trying to impose it on the entire ecosystem. So if I go back to this idea of scoping a smart contract, well, I've done my best, knowing that I'm not a computer scientist, to list over here solutions that we may want to explore to try to find a solution to this idea of immutability when indeed it is problematic. I'm not sure which one is best. I think we have to test that. There are numerous ways by which we can test. It could be lab experiments, it could be agent-based modeling, it could be sandboxes, it could be surveys, etc., etc. But in my opinion, we need to test instead of just choosing one way to tackle the problem. What you also see is that the tech can actually provide solutions and actually help regulators and policymakers to reach a legal objective. And here, let me give you a very concrete example, but I've seen something already similar being presented today. What I've done here is that I've taken a smart contract written in Solidity, and I've actually provided the code of that smart contract to GPT-3. And you get actually a translation, which is, I have to say, not too bad. You know that the system does not understand at all, right, what's behind the code. And it starts always saying the contract is simple, which of course for lawyers is already a sign that it has no clue what the system is talking about. But yet it is quite good. I mean, you could get a sense of what the smart contract is all about. My question is, isn't it worth trying to develop those solutions and try to provide that to users and consumers so that at least they know what the smart contract is all about? And coming back, and that's my final point, to the issue of the oracles, again, it could be that we want to design oracles that will actually stop information being transmitted to call on the smart contract and try to reinsert legal expertise. Now, the question is, if you say that one lawyer is in charge of indeed validating the information, then you create the trust problem, right? You have to trust that lawyer to call in a smart contract. But it could be that, for instance, NLP could be used, right? We'll check a smart contract, some sort of, well, it looks okay, just to check if the clause to stop the smart contract is here, right? If there are all the provisions that we want, and will therefore transmit information and activate the smart contract or not. So again, this is just a flavor of all the issues. I'm very much looking forward to the discussion, and I think that I'm right on time. So hopefully this was the first success of my presentation.
Extremely successful, not only in terms of time, but also in sharing your insights, Thibault, also your ideas about how to combine legal and technological solutions. Also, thank you very much on touching upon the EU EU Data Act. It was very insightful, and I think it can kickstart a very nice discussion at the end. I think it is time to pass the floor to Jori Ampluster, who is the third panelist for today. Jori is the co-founder and currently the CEO of the Ethic Hub, and he works a lot on decentralized finance and crowd lending. Therefore, it is excellent to have him today with us, because he can give us gives us insights from the battlefield. In fact, if I'm not mistaken, Jori, you will be talking to us about smart contract use cases, difficulties of users that are not so tech-affine like myself to interact with smart contracts, and also about DAOs and conscience in smart contract implementation. Jori, the floor is yours.
Thank you very much for the introduction. Let me share my screen. Do you see my screen?
Yes, we can see it's loading, I think.
Okay, so thank you very much for...
Jori, it is black now at the moment, nonetheless. It has loaded. Okay, now we can see the slides as well. Excellent. Thank you.
So, thank you for inviting. I'm Jori Ampluster, co-founder of Ethic Hub, and fully committed to leveraging on this fascinating technology for changing the world for good. And from my point of view,
Jori, sorry to interrupt you. It seems like your sound is not as good. Could you maybe try to close your camera or use your headset a little bit differently?
Yeah, now better, right?
It sounds better to me. I hope this is the case. We can try a SATs, and if further distortions are observed, I will let you know. And also, if you would like to go full screen with your presentation, it would be helpful. Thank you.
Yeah, I give it. No. So from my point of view, blockchain technology allows for a new jump, a new stage in human collaboration. Since we were invented agriculture, the next big thing was writing, because it allowed us to how do you say, pay taxes, record that this guy have paid taxes, so we could have some military or governments, etc. And we lived like that for millennia until we created accountability, accountant. So from that point, we were able to create a better human collaboration, because we were able to create private companies. Until that moment, it was just the state or the particular enterprises, and we live like that, and that was the foundation for the Industrial Revolution. And blockchain technology allow us to rethink civilization in a much different way, because it's like 3-entry accounting. And the first use case was to create decentralized money, which is super cool, because money has been always very important in our societies in order to scale and collaborate. But with the introduction of smart contracts, we were able to think on much more use cases, starting with fintech, DeFi now, which is just using that decentralized money in a new financial system that is more transparent, trustless, composable, and many other characteristics that, from my point of view, is clearly better than the traditional financial system. But not only that, we can think of much better and efficient value chains where we can automate with the smart contracts a lot of all the transactions within the value chain, creating a full traceability in it. We also can think on a real sharing economy, not like the one we have now with Uber or Airbnb, where only the shareholders are able to profit from these innovations, but also the users, all the stakeholders in the system. And rights now with NFTs is a super powerful use case. Digital identity, from my point of view, we should turn into anonymous identity systems, because what the previous speaker said, that if everything is kept in the blockchain forever, it's better that nobody knows who you are. So we should think on pseudonymous identities instead of digital identities. And finally, governance. It allows us to think on much better governance tools, leveraging on both smart contracts and crypto incentives, so people is empowered to join the public discussions in a much efficient way, and is able to ask for our managers, governors, to accomplish what they promise. And this, from my point of view, allow us to think on, we are living now in a very vertical system where there is a lot of governments and where the people at the end has very little decision on what is going to happen, to a new system where DAOs take a big role in economy. My bet is in 10 years time. I don't know how long will it take, but I bet that in the future, DAOs will be the biggest part of the economy. And in an economy where DAOs are the main actor, people is in control of what is going to happen instead of the system itself, not the status quo. We are still super early, more or less like in this, by the end of the 90s in the adoption of internet. If we compare to the adoption for internet, we are going faster than internet did, because now we have smartphones and everything, so it's much easier to implement new technologies. But up to now, there have been very little impact into the real world. So now the two use cases that impacted more the real world was in El Salvador, the implementation of Bitcoin, even though it's not smart contracts, but it did a huge financial inclusion effort. Millions of people had a digital account for the first time in their lives. And Axie Infinity, which is providing jobs for millions of people in developing economies, where they just join a metaverse, they play the assets of other players, and they get rewarded for doing so. And this is like a new economy that we can envision thanks to this fascinating technology. Other use case that is being super successful is ClimaDAO, which basically leverage on crypto incentives to get funded and buy a lot of carbon credits. And it has absorbed up to now more than 50 million tons of carbon, creating a budging pressure for this carbon. So the prices goes up. So it's more expensive to contaminate, and is more profitable to absorb carbon and plant trees or whatever. Some people say ClimaDAO is not very sustainable, but Celo is. Celo is a layer 1 blockchain in which the stable coins are collateralized 40% with natural resources. So the bigger Celo grows and the bigger the Celo dollars are created, more Celo dollars are created, the more jungles and forests are protected. And we in EntreHub, we are focused on other problem of the real world, no? Which is that almost a quarter of the world population remain excluded from the traditional financial system. This is maybe the biggest issue with the traditional financial system. So we always say that we should focus on solving the biggest problems of the traditional financial system instead of creating new solutions for something that it was not a problem before, like as we are doing now with DeFi and crypto. And if you think on how credit markets work, there is basically two ways to lend to someone. It is that they have an asset that they can use as collateral, or they have data that so you can create a credit scoring and lend based on that credit scoring. The problem is smallholder farmers, developing economies, which are the most of these unbanked, don't have either nor assets nor data to create this credit scoring. So we invented what we call crowd collateral, which means that you, with ethics staker, you buy our token and stake on behalf of the loan originators. So they have collateral. So other people are able to lend them because it exists, that collateral. And with this system model, what we are creating is this incentive loop. That is that a trustfully platform attracts lenders. The more money that is lent, the more demand for the ethics. The more demand for the ethics, the more capital in the compensation system. So the compensation system is more secure. So the platform is more trustworthy. So more people is willing to lend using the platform. And this is a crypto virtuous incentive loop, which is the main goal of crypto economics. And for my point of view, this is the real disruption of what we can do with blockchain. Crypto incentives together with DAOs allow us to think on much powerful solutions. It enables us to create a blended finance, a new way of blended finance to further accelerate impact investing in order to solve real world problems, which is what we should focus, because at the end, technology is not good or bad. The smart contracts are a super powerful technology, but the main point for me is that we are conscious, so we use this for changing the world for good, as we are all in the regenerative finance movement thinking. And this is basically what I wanted to share. And I'm looking forward for the panel discussion. Thank you very much for inviting again.
Thank you very much, Yuri. That was very insightful from the battlefield, I would say. You really helped us a lot put into perspective what kind of applications are currently influencing real life, as you mentioned, which really helps a lot on the technical and legal research that we are undertaking in these areas. Now, this concludes the synchronous presentations that we have had on this panel. I will now ask the colleagues that are in control of the organization to start broadcasting the video that was sent by Professor Ora Esther Vilalta Nicuesa, who unfortunately could not be with us. Her presentation will revolve around legal issues of smart contracts. And yes, I think we can turn now to this presentation before we carry on with the panel discussion. Thank you.
Hello, everyone. Thank you for inviting me to be part of this panel devoted to the legal challenges when dealing with smart legal contracts. I'll try to focus my attention in three basic ideas. First, on the nature of a smart legal contract. Secondly, to mention that these contracts are capable of enhancing legal transactions and the access to justice. And finally, that there's no need for a new legal framework, but only specific provisions and slight adaptations, as they bring a number of legal challenges that need to be resolved. I'll try to stick to the time allocated. So my thoughts will revolve around these three ideas, and it won't take me more than 10 minutes. After which I will try to answer a number of questions that are still left hanging in the air. So first, just a quick thought on the nature of a smart legal contract, to say that actually they are actually legal transactions where parties enter or perform fully or partially their legal obligations by means of DLT and blockchain technology, seeking a number of advantages, like, for example, getting automatic responses to legal transactions, increasing efficiency and lower costs because there's no need of human intervention, or to improve compliance, or to increase transparency, or even to reduce performance risks. And the beauty of the thing is that by doing so, they are capable of enhancing compliance and preventing conflict escalation, which means, after all, promoting a peaceful justice. So, well, worth is to mention that the academia has been struggling during a long time in order to clearly identify the distinction between smart legal contracts and smart contracts. Today, some consensus has been reached drawing a distinction between these two terms and considering that the former is any transaction that follows basically the if-then-else structure implemented in a blockchain and applied to a wide range of functionalities, while the latter refers to legal transactions where parties enter or perform a legally binding contract. The last report of Lord Chancellor in United Kingdom in November 2021 uses the term smart legal contract as a legally binding contract, in which some or all of the contractual terms are identified and performed automatically by means of a computer. These contracts can take three forms, basically: natural language contract with automated performance, hybrid contract where the natural language contract is the umbrella containing general provisions, terms or provisions, and then the individual trades are made automatically, and solely code contract where the terms are all in code language, and so we need verifiers or auditors to ensure that the code reflects the intention of the parties involved, like for example in initial offering coins. Accordingly, the legal nature of these transactions will remain unchanged, and so the current legal principles applied to traditional contracts are fully applicable to them, which does not mean that some smart legal contracts may bring new scenarios and challenges. And so there's a need to some flexibility in order to accommodate them into the existing legal framework. In any case, there's no need for a new legal framework to embrace them, just some specific arrangements or adjustments. The law should consider smart legal contracts as functional structures that accommodate any legal transaction. They truly enshrine contract law principles, like, for example, the principle of irrevocability or the pacta sunt servanda principle, ensuring that the enforcement and the performance is not left to the willingness of just one of the parties involved. Now let's answer to some of most frequent questions, like, for example, if there's any formal requirement to conclude a smart legal contract. According to the principle of formal freedom, which is applicable to contract law, there's no need of additional formalities to become a valid contract. This by no means may be interpreted as there's no need of confirmation. Confirmation can take the form of a receipt, a copy, or other supporting document containing the key terms and conditions of the legal transaction accepted by both parties. Now, is it possible to transform any legal contract to a smart legal contract? Well, the answer is no. Not all transactions or contracts can be digitalized and be performed automatically, like, for example, legal transactions where the qualities of the persons are essential, or legal contracts where there is a crucial need to assess the legal capacity of the parties involved, and the system has limited means to verify this aspect, or contracts that include nuances that when describing a legal obligation that could be of great impact or relevance to the contract. Let's think, for example, in terms like faith, good faith, standard of care, prudent man, supervening circumstances, and so on. So we need to bear in mind that smart legal contracts are very difficult to unwind. Now, when it comes to the language, can a smart legal contract become binding when the terms are only written in code language? Well, in order to be binding, the terms need to be clear and comprehensible by the parties involved. For a contract to be valid, there's a need of clear information made available, and this information may include not only the general terms and conditions of the agreement, but also the steps to be followed to enter into the agreement, the means for correcting errors, and the language in which parties will agree and resolve conflicts. Which does not mean that some smart legal contracts may be fully codified. By natural language, versions will be always necessary. Now, what if a transcription to code is defective or the inscription is not functioning well? This may entitle a party to void a contract. which may produce damages and bring intermediaries like developers, DAOs, and other participant organizations to some level of liability. And here the law has not yet proceeded to design specific legal responses to face such scenarios and for the allocation of liability. And so parties and intermediaries become vulnerable as well. Private multi-party agreements may be an early solution, but the market needs legal certainty. So some kind of harmonization with a minimum standards of liability and safe harbors are necessary here. Following with language concerns, which version of the contract should prevail in case of a discrepancy between two different versions? We need rules that will settle which version will be the authoritative one in case of controversy, having always in mind the principles of private autonomy, accessibility, and transparency. So if parties have not reached a private agreement on that, natural language versions should prevail to make sure that both have fully understood the legal implications when entering into the contract. For solely codify smart legal contracts, it should be expected that parties will engage in natural language negotiations before any agreement of such nature is reached, because a large number of countries have set consideration as a legal requirement for a contract to exist. For B2C contracts, consumers need to confirm as well that they understand that what the contract entails. Otherwise, they will not be considered bound. And it is very unlikely that the consumer will be able to read code language. So natural language versions may become mandatory in B2C transactions. Now, how to deal with conflicts where parties are not duly identified? As we all know, a contract may not be valid and enforceable in many countries unless two or more identified or identifiable natural or legal persons are involved, all of which need to have legal capacity. It is possible, though, to use pseudonyms when they are coupled with the mechanisms for a future identification and verification of parties. In machine-to-machine contracts, though the legal nature remains still unclear, and in my view, such legal transactions need a contract umbrella or a partnership between two or more legal persons as a bedrock to become fully valid under the law. Now, what if payments are made with cryptocurrencies? This is totally acceptable for a contract to use cryptocurrencies as a digital representation of value, and they can be used as a means of exchange. They can be transferred and stored. However, the law should clarify the nature and character of such contracts when the transaction does not contain the intention of the parties, because the contract can be qualified as a barter or as a sales contract, and so producing very different legal outcomes. As the time is running out, I will try to concentrate now on how to deal with discrepancies without resorting to the courts. Parties may wish to avoid a court proceeding by including a set of provisions, private provisions, and dispute resolution mechanisms to deal with future potential disputes. And smart legal contracts are capable of incorporating a wide range of solutions. Some include oracles with artificial intelligence, others include online dispute resolution mechanisms, such as arbitration or mediation, which can be assisted with artificial intelligence as well. Such dispute resolution services integrated as oracle service providers need to be genuine, neutral, and independent from the trader. Also, ex-ante consent from the parties involved may be required in case of consumers. Therefore, the law should provide specific provisions to provide proper or to ensure the proper functioning of such oracles in the market. And I will conclude here to say that there's still room for research and for improvement to be done when it comes to blockchain and smart legal contracts, because they are neither smart nor problem-free, but The practice demonstrates that they are operating pretty well in the market, and there's an evolution over time. They have a great potential to avoid and even to resolve disputes. And so in my view, these new players fully deserve a place in the online ecosystem, which means as well to clarify their role as distinct and specific cyber intermediaries from a legal perspective. Thank you.
Excellent. And with this, we are concluding the part of the interventions of our panelists, and it is time to turn to our panel discussion. And I would like to kickstart this discussion by asking our panel a question that has been looming in my mind while all four of them have been presenting. And as I promised since the beginning, it also has to do with the very recently published proposal on the EU Data Act. And it was a topic that was really was touched upon by all of them. And my question would be the following. One of the interesting ideas that one can see after skimming through the EU Data Act, personally I have only skimmed through it, I don't pretend to be any expert on it, is how to create mechanisms that would control and somehow create safeguards in order to mitigate the huge imbalance that is sometimes recorded in contracts that have to do with the exchange of data. And this imbalance might stem from two facts, especially when it comes to smart contracts. On the one hand, one might think of a user that it is not super tech-affine, and therefore a contract that it is also expressed in code might put him in a disadvantaged position. At the same time, the place that the actors have within the data market is also imbalanced. A huge, for example, company that works with data is in a better position in comparison with a small and medium-sized enterprise, especially in terms of access to data. So one of the ideas promoted in the EU Data Act is to create mechanisms in order to create a level playing field between these two actors in order for them to be able to enter contracts. And I would like to ask the panelists, the EU Data Act aside, if you happened to skim through it, of course, you could share your insights on that, but even beyond the EU Data Act, do you think, first of all, that this is an important problem? And secondly, if yes, how do you think, what do you think would be the next steps in order to mitigate it?
Well, I'm happy to give it a try. Can you hear me?
Yes, Thibaut, we can hear
Yes.
you. I was about to ask. Thank you very much for
Yes.
still being with us. Thibaut is going to give a class in a few seconds, so the fact that he's still with us is remarkable. Thank you very much.
Yes, well, thank you very much. And I'm sorry I couldn't put the video on. I think it is a concern. I'm not sure it is a specific concern with smart contract though, right? I mean, we see that problem already today without smart contract. Google and Facebook and Amazon and the big tech companies, they have ways to gather the data. And actually, I think that smart contract might be a solution that we may want to explore. And it comes back to the idea of what I tried to explain, which is that not all smart contracts should be designed in a certain way. It could be that specific smart contract to be put in place by public institutions. And I could see how this will actually help those institutions because the cost of monitoring the compliance is going down, right? Once you've put the smart contract on the chain, you know that if the conditions are met, the smart contract will be triggered. And so I think this is a great opportunity for, let's say, the European Commission to put in place specific smart contracts, organizing the way we share data or whether or not data stays in the hands of the consumers. Of course, we have to discuss whether or not this is efficient. I doubt it, actually. I'm not sure that startups need the exact same data than the big companies. But when it comes to B2C, I think, again, smart contract might, with the help of public institutions, create something by which you know that compliance will be made by design, which is a real chance. So I don't know if I answer your question, but yeah, this is my best try.
Thank you, Thibaut. That was very insightful. And I have a follow-up question, but I think I would like to pass the floor to us first, because I think it is your turn to share a comment.
I agree with Thibaut, actually. And I thought it was a really interesting question, Yadis. until the recent, I mean, there was a recent, was it a fine of Google Analytics? There was, or a case against Google Analytics where, you know, they were, where their access to data was highlighted and how that creates such a huge competitive disadvantage for everybody else. It wasn't something I'd really ever thought of. So obviously it is a much bigger problem, you know, than anticipated if, you know, an act is coming out to try and address that problem. What I found interesting about the Data Act is they're using smart contracts as a solution. And I think, you know, it's the suggested solution. It's the suggested infrastructure to try and cure this problem, and probably many others. And I just think it's fascinating. You know, we're just beginning to see how smart contracts can be used. And it's amazing to think that, you know, we're going to pull that in. You know, initially it was, oh, blockchain is bad, smart contracts are bad, Bitcoin is bad, you know, the hacking, the ransom, etc. And it's like, oh, we can use that for ourselves. Great, you know, yay, smart contracts. So I thought that was the most interesting thing, an interesting thing about the Data Act.
Excellent, thank you very much, Asens. I would agree that especially we people with a legal background, we have a natural reflex against anything new and technological. I remember, for example, that like blockchain recently, even the internet in the early days was deemed as something evil and that the laws would take it down somehow or stop them. But nonetheless, the internet not only perseveres, but if one looks at the legislative initiatives of the European Commission nowadays, one will see that the internet is considered something good for the well-being of society. So I do believe that we will have that curve with blockchain applications as well. And I agree that what you mentioned about smart contracts, the fact that they are untested yet, but nonetheless we are willing to give it a try, I think it can only be an encouraging sign. Yuri, I think it is your turn. I think that you talked a lot about those that are unprivileged, and you also tried to explain how smart contracts can help mitigate such risk. So please, if you'd like to make a comment, go ahead.
So I would add that at the end, the main issue for me in this regard is that regulators don't understand the technology, and nor do we. We are in super early stage. It's like trying to regulate the internet in the 90s or trying to regulate the cars when they were invented. No, in United Kingdom they said this, like before the car, somebody have to go with a I don't know, doing some noise or something. No, so nobody is being hurt by the cars. Always at the beginning, regulators think technology is bad, and that will change with time, I'm pretty sure. And for me, regulation should promote and allow innovation. So countries that enable these new potentials to arise take a step forward in their situation in the world. And most importantly than that, at the end, is that we as a society, education for the people to use this for the good and not just to trade or speculate or even steal to others.
Thank you, Yuri. It is encouraging that you said that regulation will help the technology flourish, because these are usually treated as fundamentally opposing one another. Thibaut, I think you want to interject.
Yes, and to say that I fully agree. So, you know, you mentioned the internet. Indeed, if you go back to the archives of the New York Times in the 90s, you will see that internet is just for pedophiles and criminals, right?
Yes.
And so, but it actually goes way. I mean, it's a very long story, and this relationship of, you know, confrontation between law and tech is actually, I think, dates back from the Code of Hammurabi. We've been doing it the exact same way, which was you put water on your fields, you irrigate the canal, you irrigate your field by opening the canals. If you overflow your field, then you have to compensate your neighbor, which again is just looking at the problems. And I understand why, you know, as a professor of law, it would be curious to say that it's for me to enter the classroom and to say, today I'm going to talk about when everything goes well, because this is not what we do as lawyers. And yet I think it's important for us to consider that so that when you regulate the problems, you do it in a way to preserve the potential, right? So we just talk about the potential for data sharing. Great. But what if you say that, the immutability of smart contract is problematic, and it can be? Well, then you kill, the potential of using it for data sharing and automating data sharing. So I think it's very important that we take into consideration the potential of the technology so that we tackle the problems in a way to preserve the potential if possible. So I couldn't agree more with what has been said.
Absolutely. Thank you, Thibault. Ash, I think you would like to interject something.
Yeah, and I think following on from that point, the Dow Act mentions, standards and interoperability. And I think maybe it's too soon to impose this. We don't know what they're capable of. And I think before we police them, we let them develop and see what happens. We haven't had them very long. We've seen their work in DAOs and NFTs and just dApps and regular blockchain applications. We don't know what else they're capable of. It's way too soon. And I think it's conflicts a little bit with the approach of the Commission when it comes to a regulatory sandbox for crypto assets. Let them play and see what happens with the crypto assets. And yet, the building blocks for the crypto assets, they want to impose standards on those. And I think, no, you can't impose standards on the building blocks of something that you're, letting people use in the sandbox. And I think that bit of, the Data Act is wrong.
Absolutely, and just a side thought that only adds slightly to what you just said, Ash, is that sandboxes are also embraced by the AI Act. So maybe it's something that we should consider about all the building blocks of the upcoming digital futures, for sure. And as we were discussing, my mind was traveling in two different directions. So I have two side questions on the original discussion that we had. The first one was, smart contracts can be a solution to the problem, but those of you present in this panel today, do you see any possible limitations of smart contracts as solutions? For example, what comes into my mind is the problem of interpretation. While we have had problems of interpreting contracts that have been written in human language so far, how can we do the same for contracts that are written in code? Can somebody misinterpret code? Or is code objective one, so this is not a problem at all? But if it is a problem, how to mitigate that? I think I will start with Thibault because he's running Yuri, and I'll return to you, sorry.
Okay.
Yes, thanks very much. Now, I wanted to say again, yes, it's a problem. It's not a new problem though, right? I mean, you do have the same problem with natural language. And actually, again, the chance of smart contracts is that you may actually run the smart contract, right, on a network which is not the main network and see what's the result coming out of it, which is not something that you can do with a natural language contract. So it is a problem. We have some solutions. Again, you can run simulation. You could use GPT-3 to try to understand what's behind the code. But for sure, this is something that is to be discussed. And I just wanted to say for the interoperability, again, I very much agree. We do have empirical work actually on the subject coming out of Jean Tirole, the French economist who won the Nobel Prize, showing that most of the time, interoperability, it's good when it's bottom up, right? When the players want it and actually start working on those solutions. But to impose it is generally a way to actually slow down innovation, and it might be way too early for us to go in this direction. So potentially, to sum up, to answer your question right now is more pressing and more important than trying to impose interoperability standards.
Excellent. Yuri, please.
So I wanted to add in this regard that what we are doing with smallholder farmers in developing economies, and sometimes they don't even know how to write or read. So yeah, interacting with a smart contract is a big challenge for them and for us if we want to work with them. And in general, not only smallholders farmers in developing economies, the user experience of all what we are building right now is super tough to use. You have to install MetaMask, you have to understand what's blockchain, what is a smart contract. Now that you can read the smart contract in Etherscan and understand that the smart contract is quite a thing. So I think we are extremely.
Thanks for saying so, Jorin. I was afraid that I'm the only one who doesn't understand MetaMask because I got a bit, sad in the beginning.
Yeah, and not only MetaMask, but if you go to to Solana or to Cosmos, you have to install another plugin, and in each blockchain, the Block Scout, the Explorer is different, and you have to learn about a lot of them. So it's super complex. I think there is a long way until this is more or less useful as internet is. I remember in the 90s, using internet was super tough. You have to configure the DNS and everything, and the internet connection.
If the connection would not fail, right?
Yeah, so it's something like that. So this is not still ready for mass production. That's my point. And I have to jump because I have a meeting. And I thank you very much for.
Thank you, Yori. I would pass the floor to us in any case because it's her turn. And with Ash's interjection, I think I will conclude the panel discussion because we are making use of extra time already. But for the questions that have appeared on the Q&A session, they will not remain unanswered. The organizers of the event will make sure that they will be answered and it will be included in the report of the webinar. So Ash, please, you have the final word.
I'll reiterate what Yuri and Thibaut said there about the interoperability of blockchains. Blockchains started off and they were very siloed. We're only now beginning to move into where you had pocket reporters, which was one of the first protocols which allowed for interoperability between certain aspects of gaming platforms, and now you have blockchain platforms and protocols which are building interoperability, and that's that. They've been tried and tested. They've played with the hashing, and now you're getting layer 0 ones, layer 0 protocols, which are also allowing for interoperability. So I think it's too early to police smart contracts. Let's see how they develop, just like we let blockchain develop. I think it'd be interesting to see what happens.
Excellent. Thank you so much, Ash. A huge thank you to the panelists and also to our audience for this very lively discussion. I will pass the floor to Christian, who will have the final word of the day. Thank you, Christian, very much. Also for inviting me to moderate.
Excellent. Thank you for coming in and for the excellent job you've done. I'm not going to try to draw any overarching conclusions. I think the experts we've heard from today are much better placed to do that sort of thing than I am. I'm not sure we are at a stage in smart contracts where we can draw full and final conclusions anyway, but I think we can all agree that there's huge potential in smart contracts, and I would encourage you all, instead of concluding, to keep the debate going, voice your views, both on smart contracts as well as other blockchain-related matters, through the Observatory and forum on EUBlockchainforum.eu. And I would like to take this opportunity to thank our keynote speakers, our panelists, our moderators, and of course the European Commission for facilitating all of this. And with that said, go to the EUBlockchainforum.eu. There you can engage, you can find the latest reports we have and the future events. Thank you very much, everybody. I wish you a great morning, day, or night, wherever you are in the world, and hope to see you next time.
Thank you very much.
Thanks, everyone.
Thanks, everyone.
Thank you.
Bye. Thank you very much. Bye. Take care.
Thanks a lot. Bye.
Go.